Okay. Hello. Hey, Thunder. 2480 exactly. Nice. YouTube stream seems to be live. Okay. How's it going, Thunder? It's been a minute. Learning logarithms. Oh, nice. Oh, it's been good for me too. You know, I think you mentioned a long time ago that you like to listen to your own music. Hey, hoo hoo. How are you? And at least for the moment, over on YouTube, I don't have any music. So if that's something that you felt strongly about, you could watch through there. But you're welcome on either platform. But and also I'm not supposed to specifically tell people to not watch through Twitch, which is why I have this awful cough. But I just want to like let you know about that in case you preferred that. You're good? Nice. I'm good too. Had a good little 2 days off. Let's look through I feel like I just did something that was fun. No, I don't think I did. Never mind. What was this problem? Oh yeah, they had to get the oscillating circle. Which was new for me, but I think I figured out how to do it. Oh, interesting. They never covered implicit differentiation. Let me see if I can give them a... resource. It sounds like they're already on board with the idea, but let's at least give them Paul's notes on it. Anders. Another explanation. Example problems. I like this website for all things calculus. Good. All right, let's post this. All right, let's look for new questions. Complex probability? As in imaginary numbers? Or just complicated? I think just complicated. I was like, how do imaginary numbers have anything to do with probability? Maybe there is some kind of intersection there, but I don't think I want to know it. This is a little bit too long and I'm not too good with probabilities. So I'm going to move on from this one. I should just go straight over to homework help. Not straight over, but, nearly. Bookbinder, how are you? Good to see you. Wait. Oh, why? That should have happened, Bookbinder. I'm so wait. I should figure that out. I didn't. I bot shouldn't have done that. I'm sorry. Nightbot needs to calm its tits. Log in. Now, is this my YouTube Nightbot or my Twitch Nightbot? Who's to say? Okay, it's my Twitch. I thought I... Oh, no, I didn't... Oh, my God. Disable all this automod stuff. Okay, you should be able to do caps to your heart's content, Bookbinder. We don't have complex numbers? Oh, okay, Anders. Oh, yeah, no, sorry. So someone over on YouTube got timed out by Nightbot because they said hello in all caps. It's okay? Okay. I'm glad that you're back and able to type. Nightbot should be a bit calmer now. I don't think anything else I need to turn off. Okay. So, welcome to the stream that you get. You get a timeout. I'm gonna find the person who was so sick in the head that made regular shapes using complex numbers. Like circles and stuff? Yeah. Find the anagon in complex numbers? That sounds painful. I guess it's basically doing it in polar coordinates. I'm sure it's possible. Because I know you can do a straight line in polar coordinates, it just looks a little weird. You have your board exams after 1 month and you're scared and nervous? Oh, dang. Well, good luck. Like board exams, like, what is that for? I think of like a medical student for some reason, but what are you studying? I'm sorry if I've asked you that before. State board exams? Oh, for like a certification or something? Commerce. Maths? Oh, okay. Woke up one day and decided to do geometric series with complex numbers. If like the ideas with real numbers short transfer over, that might not be too bad, but it could get more complicated, I guess. Well, that's interesting, the Bookbinder. Good luck with it. Yeah, I guess being scared and nervous is just kind of a part of having a big test like that, but you still got time to, like, prepare and not go into completely blind. It looks like gobbledygook. Yeah. I can see how that could get really messy. Oh, this person's just posting their entire homework. They all comment on them too, so. I'm gonna score 90+%. How common is that on the test, if you know? You got a question, Thunder? Yeah, let's hear it. It's hard? Oh, okay. You gotta work hard? Yeah. It's I'm sure if it was easy, then everyone would do it. So best wishes with that test. Oh, looks like you posted it. Let's see. Question 4, part A and B. You got a stroke for the 499th time reading this. So 4A and B here. Oh gosh. Okay. The convergent infinite series C and S are defined as 1 plus 1/3 cosine theta plus 1/9 cosine 2 theta. Okay, so this looks like powers of a complex number. Similar with sine. Bookbinder, I'm decent with differential equations. If you want to like put an example question, you can type it out in chat. Or you can, if it's easier, you can put a picture in my Discord. Whatever's easier for you. You don't know how you're alive? Show that C plus IS is equal to 3 over 3 minus e to the I theta. I think we'd have to work it out just for C, work it out just for S, multiply the S by I, and then add them. Like, are you just showing this for fun, or do you want me, or do you want to actually like see me try to do it? I'm the best with complex numbers, but I think I can do this one. I don't see typing back Thunder. I'll just go ahead and try this problem. It does look kind of fun. Okay, I just put some fresh ink in my black marker too, so hopefully it'll look nice on the board. So trying to figure out, let's try to figure out just C for now. You find it difficult to identify whether you should form dy by dx or separate those terms. Okay, in general, Bookbinder, I would tell you like put like separation of variables. I personally like it whenever I can do it, because it's just a little bit like more intuitive to me. So I would always look for separation variables first. And sometimes I'm bad and I forget to, but I think by forming dy by dx, I might have learned that with the term integrating factor, which is the way that will always work. That separation of variables I think of is more like a nice like shortcut that can save you a lot of work compared to an integrating factor. All right, so let's take a look at the series just for C. 1 plus 1/3 cosine theta plus 1/9 cosine 2 theta plus ... So these are all powers of a number, that's for sure. We need to So how does the cosine come back up to the numerator, actually? I'm getting... Oh, you know, Bookbinder, before I forget, whenever I get the opportunity to, I always love to link Paul's online notes. They have a section on differential equations if you want more practice. So like this first section is on or the thing I liked is a section on an integrating factor, or like, you know, just working with dy by dx. In the section after that is separation of variables, if you want more like examples and things. Basically physics. So, Thunder, were you able to do these and you're just show me your fun, or do you want to see me? Do you have no idea how this works? Okay, I'm trying to figure out how this works for myself, so. Maybe it's better to look at their sum as a whole. That might make things more clear what's happening. Oops, not cosine. Oh, the black erase is so nice when the ink is new. So I was thinking of looking at C and S separately, but it sure seems like we need to look at them combined if I want to use, what's it called? Euler's identity. So C plus I, what the heck am I writing? C plus IS, so I'll take the 1, and I'm just going to treat that as its own thing, but then I'm going to take the 1/3 sine and the 1/3 cosine and kind of mash them together. I'll put it in brackets, just like group them, and I'll factor out the 1/3. Cosine theta. What the heck? Dude, it's like my brain and my hand are not in sync at all. And then the 1/9 and the 1/9. And remember the I has to be there too, because the I is there. I think I was doing parentheses because of this part of the problem. Okay. Oh, see you, bookbinder. Sorry I missed that. And good luck. And Tayden, welcome in. What kind of math questions are you able to answer? Is algebra or any kind of math? I will try to answer anything that I have knowledge of, and I have knowledge of algebra, geometry, trig, pre-calc, calc, and your normal differential equations, like not partial differential equations, but like ordinary differential equations, I guess I should say. Stats as well. So like I'll do anything that's basically like calculus and below. After calculus, it gets a little bit sketchy, but I'm pretty comfortable with differential equations. And so yeah, Thunder, you're saying e to the theta over 2 is equal to, or e to the theta over 2 minus e to the theta over 2 is equal to, okay, so that's sine's imaginary definition. I don't know if we'll need it for this one though. Oh, Bode the Bode, thanks for the follow, and hello to you too. I want to use Euler's in here, which is e to the I theta is equal to cosine theta plus I sine theta. And if there's a coefficient that goes inside of the argument, and we're also going to have basically the R in front, I guess, which is the R just gets multiplied. Okay, let me actually, maybe is it the Demoivres? Yeah, Demoivre. So you have to say it with a Boston accent. It's Prav, you lost your old account? Oh no. It's pretty great. How often are you live? So you know how often it's possible to get help? That's something I should get on YouTube. My schedule is Monday, Wednesday, oh sorry, Tuesday, Thursday, I'm typing this in chat. Tuesday, Thursday, Saturday at 1 p.m. Pacific. Basically, I start 20 minutes ago on Tuesdays, Thursdays, and Saturdays. And I have a Discord where you can ask me a question, and if I'm not online, I'll get back to you as soon as I'm available or the next time I'm live. And if you really want someone who's live and I'm not live, over on Twitch, there's a whole community of math streamers who will answer your question live. But of course, if you don't want to go to Twitch, that's completely fine. See ya, Bookbinder. Love you too. So yeah, I hope that I didn't just like overload you with information tied in, but that's stuff that I should probably all get into my YouTube descriptions. So thank you for asking that and putting that. Let me make a note of that once I'm so I can update it once I turn off the stream. Put schedule and other streamer info in YouTube description. Here we go. So yeah, right now we're working on a problem that's probably a little bit beyond my normal wheelhouse because it involves complex numbers and I'm not too good with them, but I think it doesn't use anything that's too crazy, so I should be able to figure it out. I just want to confirm what Demov's theorem is before I continue. Eastern Standard Time. How do you access that? I just found your channel by clicking live math. Oh, hey. Thanks for subbing. I'm still working getting YouTube alerts. Oh yeah, so Twitch is a completely different website. It's where I have like streamed primarily, and this is my second week ever streaming it on YouTube. But it's another or not another, but it is a live streaming website just called twitch.tv. It's mostly about gaming, but there's a small niche for math, I guess. If you want to just stay on YouTube, it's completely up to you, though. I'm streaming to both simultaneously right now. So there's a chat up at the top there. That's just like the Twitch chat. Okay, the site finally loaded. So yeah, this is the Demov's theorem that I want. Oh yeah, but that might be a more applicable version of it. Okay, so I much prefer how Bode wrote it, although this way is also basically the same thing. Oh, were you? Oh yes, we're going to need that. Thunder. And actually, that's slightly different from the equation for real numbers. So I'm glad you you posted that. We'll come back to this in a second, though. We still have to get it to this stage. Before going, when will be your next live YouTube session? Thursday at the same time. My math streams are Tuesday, Thursday, and Saturday, always at the same time. So we have Demov's theorem, which is a complex number z to the n is equal to r to the n times cosine n theta plus I sine n theta. But, oh god, I'm mixing my parentheses and brackets. Z to the n is any complex number we want, and these are also complex numbers, so we can get this kind of relationship with 1/3 cosine n theta. How did you write it, Bode? Okay, yeah, you just did it with like the base case, which is also fine. I'm just gonna call this. I'm maybe call it. Oh god, I'm really mixing my notation. If we have r, let's say k theta, because I need another constant here. I sine k theta to the n is equal to now this r to the n cosine whatever was there before k theta gets multiplied by n. That's the whole nk thing. I think is a little bit confusing. I should just do what Bo did and just keep it as just theta. I think that's a bit simpler to look at. And this fact is going to come in handy. All right, see you Thursday, Bookbinder. Ah, shoot, I forgot to take down the cam. Okay. And be mindful that I'm about to get cut off by the problem. Okay. So now we need to look at these as powers of the same complex number. So I want to call all of these. Okay. Is equal to the sum from n equals, I think we're going to do 0, and I'll show why in a minute. N equals 0 to infinity of, well, we have powers of a third here, including 1 is a power of a third, because 1/3 to the 0. So we have 1/3 to the n. Well, I could write this in two different ways, I guess, and debating which one is more clear what's happening. Let me just write it like this. Oh, God. Yeah. I'll just write it like this, but I feel like there's a bunch of ways you could write this that might make it more clear. But I'll write it like this and just try to explain it to the end, which is also equal to 1/3 to the n cosine n theta plus I sine n theta. This, from here to here, we use this fact. Bob, no, they're not mixed. The chat on screen is only YouTube, or it's only Twitch chat because of that policy. Okay, and so this was what I was trying to build towards. But looking over at the format you have here, it's to infinity because we have the dot 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 under. So, well, there are two formulas. There's the n-1 formula, but there's also the infinity formula. Yeah, it might be easier in exponential form, Bob. when I actually look at it. Well, since each of our individual, or so the individual series here have the dot dot dot, they both go off to infinity. So we sum them together, it still goes off to infinity. So our summation is going to be up to, like, because we're dealing with an infinite sum here, we should use the second one here. And we need to figure out how to get it into this form, which we don't have the constant multiple. I mean, I guess W is equal to 1, which is tripping me up. I think we just put it into exponential form. Like, maybe not even worry about this. Although it's also valid. But a more convenient form might be 1/3 e to the I theta to the power of n. And this is our rate. I don't know how you, like, what's the radius of convergence for a complex geometric series? Okay, it's still the same thing, just the magnitude of z is less than 1. Which I guess? Well, okay, they said show it was a certain thing. This is circle of radius 1? Okay. Thank you for that, Bob. We're supposed to get 3 over 3 minus e to the I theta. Interval is 1D circle. Oh, yeah. So that makes sense, Bob. And the circle's only getting smaller as we go to increasing powers, so. Alright, so this is a, well, yeah, radius 1 because we start with n equals 0. Okay. So why am I getting tripped up on this? Why is it 3? Maybe, oh, I think I know what they did. Okay. These, if we just apply the formula from this, our W is 1, so 1 over 1 minus 1/3 e to the I theta. And then they multiply by 3 over 3. Which is what was confusing me. Okay. So that's how you can get to the answer. But Thunder, you were saying that I did it a different way? Some weird BS with rationalizing. You're multiplying the top and bottom of the fraction by... Better. Well, yeah, you shaved your beard. That's like sacrilegious. But you know, your chin is so great that I think it's still in the running for best beard. Yeah. Can you explain a little more on why you use the second one rather than the first? The second one, like this second one? And else, I didn't end up actually using this. I didn't end up using the mobs at all, which I didn't think would be true. Well, no, I guess I did use the mobs. I just did it implicitly. Because you have to do the mobs basically in reverse to figure out that it's powers. You know about the problem mode? Feel free to type it in chat or put it in the Discord. The second formula rather than the first one you put in disk? Okay, I'll take a look at it after Thunder's problem here. So... I'm really using both. I'm really using either formula that you want. It might be a bit more clear if you just use the first one, to be honest. Because z is just any complex number you want, raised to a power. And the important realization here is that the two thetas are going to become a power of 2. Which follows either of these formulas where like the power goes inside of the parentheses. We're just doing it from right to left rather than left to right. So the only difference between these two formulas is that instead of z, I just specifically wrote a polar complex number, but you could have just left it as z, and it's still completely the same thing. By mod z is less than 1. Is mod z like the magnitude? It's like, It's because, like, did you learn a geometric series just as part of with real numbers? Because you didn't? Oh gosh. Okay, so I don't want this website. Okay, I'll just explain it in terms of real numbers on my own. So for now, let's forget about complex numbers. If you have a geometric series is adding powers of a number. So if you have from n equals 1 to infinity, let's say 1/3 to the n, you start from, I guess we can do 0. It doesn't matter too much, but you start from 0, so you get 1 plus 1/3 plus 1/9 plus 1/27 plus ... And you can see each term is decreasing. That's the most important part here. Yeah, Bob, so I'm trying to like put it in real terms because that's what I'm more familiar with, but I think the point is that complex is going to be the exact same. And so you can kind of see how like it kind of makes sense because it's decreasing. It's probably going to converge to one thing, or at least, you know, that's what intuition would tell you. And, you know, we do have the convenient formula. It's going to be 1 over 1 minus r, which is 1/3, which is whatever that is, 3 over 2. But let's look at a different case. If, say, we have 2 to the n, then you get 1 plus 2 plus 4 plus, not 6, 8, 16 plus ... And so that's not really, that's just, it's going to shoot off to infinity. It's exponential, which that's also exponential, but it's decreasing. So this, you can't really, it's not going to go just to one number as cleanly as this one is, because this is increasing very quickly. And the key idea for why this one converges and this one diverges is that if your general form of a geometric series is some beginning term times r to the n, this formula for its sum is only valid when the absolute value of r is less than 1. Because your rate has to be less than 1 like it was here for you to have a decreasing series. And if it's greater than 1, then you just shoot off to infinity. And for complex numbers, I think it's the exact same idea. Where the magnitude instead of absolute value, or mod, has to be less than 1. So you're decreasing and getting closer to 0 each term. So that got me tripped up because I'm not too used to complex numbers, but if you plug n equals 0 into this, you just get 1. And, well, that's an interesting question. So it's less than 1, not less than or equal to 1. So no, your r is still... Okay, no, this is still your r. And so I think, as Bob said, this number here is a circle of radius 1/3. And you keep on multiplying by this circle of radius 1/3. And so the mod of that complex number is less than 1. I think is the explanation. Wait, Bob? Oh God, did I do something wrong? I would believe it. You want to show me the coolness? Okay. Do you want to actually talk, or do you want to just like link me, or? Sure, VC. Okay. um. Okay. I'm in my Discord. Is my Discord, does it have the right microphone? Let me check that. Okay, yeah.
Tony, what's up, man?
Nothing much. How about you?
Long time.
Yeah.
Well, too much work on my hand. Can't even. But I can lurk in the chat, so yeah.
It's appreciated.
So here's like one random time that I was just thinking about it. I just figured out this cool proof about how you get the result, which is never shown. So I don't know if I was the one to invented it, but I probably am not because it's math. You never do something first, you know?
Yeah. Let me get the Discord on the screen.
Yeah. So, like the proof of geometric series, you start with x, then you multiply by q, x, then q squared x, plus q to the power of third x, so on. Wait. Am I thinking about something else? No, yeah, the x is like the starting value, right?
Right, yeah.
Yeah. So I just figured out that if you can just pull out the q here, you will just get x plus qx plus
Oh,
q squared x plus and you would just get an s back, right?
right.
So you pretty much do this plus q s and then solve for x for s, and you have the proof.
Oh,
So that would be
what
like.
the heck?
So I just like randomly thought of that and thought it was so cool. I just wanted to showcase this.
Yeah, I didn't know where you're going. Wow, that's so simple. I never even like realized that.
Right? Like I remember I was just messing around with it one day and just like, wait, why is it not shown like this? Like the normal way you show it is that you multiply it by 1 minus q and it magically cancels out and some, stuff. And you get like
Oh,
a sequence and then for infinity. But this looks just so much cooler,
yeah, and q equals 1, like, isn't really that much of a concern, so.
Yeah. I mean, of course you have to make the bounds so it converges, but
Oh, Bo is saying that they've seen it before in a book.
god damn it.
Yeah.
But okay, maybe I did not invent it, which is yeah, definitely expected. But I found it out myself,
Yeah.
which I was the proudest man alive for that.
No, that's super neat.
Yeah. So, anyways,
All
that's
right.
it for me.
Thanks for sharing.
I'll go back to lurking. See ya.
Okay. See ya. Okay. So yeah, Bob just showed a really cool proof for why that formula works, or I should say, why the second formula works. Or it at least coincidentally gets the right answer. I don't know if it's like valid or not. I don't know enough to tell about it, but it seems valid. So, okay, so let me. So we set up our B to do from Thunder's problem, and then Bode also posted a question. Let me see if Bode's is quick. I'll switch over to Bode's, but if not, I may need to ask if you can hold on for another little bit, Bode. Oh gosh. No, this is not going to be quick for me. I don't know if I could even do this in the first place. I'll give it my best shot, Bode, but I'm gonna do thunders first. I feel more confident that I can do thunders. We can skip part B. It's your call, Thunder. I'm happy to work on it. Do bodes? Okay. I'll say I might just look at part B later anyway for fun, because it's kind of interesting to try and learn a bit more about complex numbers, but I'm gonna leave the problem up here for a minute, and I'm gonna put my mug away because I'm out of tea. Good luck. Okay, so you said you needed help with this problem, right, Bill? You're not just like giving this to me to like bully me. Okay. Consider a set P sub 2n of 2 endpoints placed equidistantly on a circle. A perfect match. Oh. Okay. A perfect matching on this point set is comprised of n straight line segments whose endpoints constitute P sub 2n. Is that n? Okay, yeah. Whose endpoints constitute P sub 2n. So, P sub 2n is a set of all diameters? Wait, no, 2 endpoints. No, all chords such that the midpoint... No. What does this mean? I'm literally stuck on the first sentence. I literally don't know what the first sentence means. For any integer n greater than or equal to 1, to consider a set P sub 2n of 2 endpoints placed equidistantly on a circle. So if n equals 1, we'd say P sub 2 are 2 points placed equidistantly on a circle? Isn't that any diameter? Oh, and then if n equals 2, you need 4 equidistant points, so it's any square. Okay, so maybe I do understand this now. N equals 3 is any 3, or as any 6 equidistant points, so it's any hexagon inside a circle. Okay. Oh wait, no, they're not just adjacently equidistant though. They have to be all equidistant, don't they? That doesn't make sense though. No, I'm still confused. It's like a perfect n-gon. Okay, so we're inscribing regular n-gons into a circle of an even number of sides. Okay, so regular 2 n-gon. Okay, a perfect matching on this point set is comprised of n straight line segments whose endpoints constitute P sub 2n. All the lines connecting the vertices of the n-gon? I guess. Let m sub n denote the set of all non-crossing perfect matchings on P sub 2n. Okay. So basically the borders plus some of the diagonals are, oh god, okay. A perfect matching M belongs to M, fancy M sub n is said to be centrally symmetric if it is invariant under point reflection at the circle center. Determine the function of M. Oh god. Well, at a minimum, the borders of the n-gon are going to be a part of fancy M sub n. And it would be centrally symmetric. But then you have the diagonals to worry about, and it seems like it depends on the n-gon. This one might be to make a bijection. I don't even know, like, I don't even have an idea. I'm trying to think, but I don't think I'm gonna be able to do this one, but I'm sorry. I don't think I have that much to contribute here. It's like I could go through cases and try and figure out some example values, but I don't even know then how you would do much with that. For n equals 1, I guess that you only have one diameter and that's it. For n equals 2, you have a square. So you take the 4 sides, and neither of the diagonals work because they vary under point reflection at the center. So that'd be what, 4 when n equals 2? If n equals 3 with a hexagon, that's where I'm starting to get a little bit. Ugh. No, I'm sorry, Bode. I don't know. I feel like I'm not even like thinking about the problem right. Yeah, I wish I was better at problems like these, but yeah. It's a pretty hard problem. Yeah, it seems like it. So at least just for fun, I want to see if I can do part B of Thunder's problem up here. This seems like it's some kind of half-angle business. But I don't think it's going to actually involve half-angle. Oh, maybe you just look at C on its own and you try to use a similar technique, but you can't use the same formula. Highest scoring points tally for this problem on the comp was 5 out of 7. The second highest is 3 out of 7. Jeez. Yeah. I believe it. I'm not sure exactly where to go with part B here, but maybe let's just try manipulating some things, because I guess the C series is the real number 1/3? With theta equals 0? But I don't think you're allowed to say theta equals 0. It doesn't feel right. Oh, who's that? Becky R6, thanks for the follow. And you got me to 450 followers, so thank you especially for that. Hello to you. How's it going? How good at math are you? I always get nervous when someone asks me that question, but I have a bachelor's in applied math. And in terms of questions that I can answer, usually like calculus and below, differential equations I'm pretty decent at, but then outside of that realm, I really don't know much. Hyperbolic functions. I haven't worked with those too much, but depending on what you're doing, I might be able to figure it out. If you have a question, please just like type it in chat, or if it's easier, you can put a question in, or you can put a screenshot in my Discord. So it's just like manipulating hyperbolic functions, doing things like that. I'll need to Google some things, but I should be able to work it out. And that's convenient because I'm realizing that I don't have that good of an idea for part B here anyway. Like Freefall? Really? I haven't heard of a hyperbolic function being used for like to model a falling object. I guess maybe I need to see the actual problem. No worries. It says hence, so I feel like we need to rely on our previous step in some way. Do you take this expression for C plus IS and subtract out IS? I don't really know what that... I don't know where you go with that, though. This one you might need some weird exponential definitions of trig functions, maybe. That Thunder was alluding to. Because I think that's where Thunder was going with it. Hmm. I feel like I can do this problem. I mean, maybe I should just try the idea that I said and see where it goes. Or see if it leads to anything. So C plus IS is the formula that we just showed. E to the I theta minus then that whole thing, which is where I'm getting confused on what we do after. This feels like it's the wrong path because it's jumping the gun. We don't know an expression for IS yet. And that's not even IS, that was just S. I didn't put the I in front, but either way. Yeah, this feels like we need to use the complex definition for sine and cosine. Sorry, I'm pronouncing that wrong. Can you do the problem x minus 1 to the fourth equals x plus 1 to the fourth? I think I can figure that one out. And I'm kind of, yeah, it's a good moment to take a break from this problem anyway. Andre, welcome in. Fourier transforms, I'm really not comfortable with. I'm sorry about that. Like, I think I learned Fourier transforms a tiny bit in school, but I've forgotten it all, so. I'm sorry, but I won't be able to do that one. But for Unge, we have x minus 1 to the fourth is equal to x plus 1 to the fourth. So, is there an issue with taking the fourth root of each side? I can see just by looking at it that x equals 0 should work. Would x equals 1 and x equals negative 1 work? I think it would. I feel like negative 1, 0, and 1 are going to be the answers here. But it's obviously, it doesn't feel right to just like look at it and say that that's the answer. So if we did, if we take the fourth of each side, we're actually gonna get too many cancellations. And what can we do? Actually, wait, 1 and negative 1 certainly, they do not work. Is it just 0? You know what? Answer involves complex numbers. Oh, well. That makes it more complicated. So are you asking me this question for fun, Ange, or are you actually asking for like help with it? Just so I know like if I'm trying to like explain it to you or just discussing an interesting problem. Because I guess you would if we're talking about complex numbers, then dude, I don't know. I'm not good with complex numbers. I'm interested to see what Wolfram Alpha says about it, but I get the feeling this is just a for fun problem from what you're saying, so I'm just gonna look at the answer. So 0, okay, minus I and I is what I was thinking rather than negative 1 and 1. So from a problem set, you shouldn't need post it in like math homework help, Beppy. You only need a role to post in like the top channels, but all the ones below that first section is free for everyone to post in, so it should be. Oh, okay. It is for your homework, Unge. So you take the root of a complex number, what happens? Does de Moivre still apply? No, that's for positive integer n. Yeah, that's the number of root. Ah, no, what the heck did I just... Stop, go away. Here, Beffy, I'll post it here. I just added you in a thread where you can post the question, hopefully. If you can't post there, please tell me, because something's wrong with the Discord. Okay, no worries. Oh gosh, yeah, so but I'm gonna look at Bevy's question first once they post it, but in the meantime I'll try and figure out your question. I'm not very good with complex numbers, so I'm trying to figure out. I assume you still need to take the fourth root of each side here. I'm just not sure exactly how you go about doing that. Or do you? I don't know. Oh, air resistance. Okay. Um, okay, so Beppy asked first, so I'm going to switch over to their question. Okay, I'll keep trying with yours. I'm not super confident in being able to get a good answer for it. But since Beppy asked first, I'm going to go with what they asked first. Set up a differential equation that describes the speed of a falling body. Yeah, thanks for asking. I'm sure I could figure out with enough time. I'm just like, I'm gonna have to do some and umming as I try and work through it. A muffin tin slash cupcake tin. That's a very specific object, but okay. Value for the shape factor of the body. Ooh. See, I definitely don't know this offhand. I think air resistance, you normally say... I think... The way that I learned air resistance... We didn't even think about the shape of the body, but we just... Looked in terms of the acceleration, so what number or what letters do you use? Okay. We said that dv dt is equal to... I guess we can define down as up. For the sake of this problem, it doesn't actually matter as long as we're consistent. So the acceleration due to gravity going down, which is we're defining as positive, or at least I have, minus some constant, which is air resistance, times the current velocity v. That's my recollection of how you account for air resistance in general with the differential equation, and then you have to work out what k is. But you also have a second thing, which is the shape factor of the body. Which actually, I think that might be K. That might be included in K at least. There's a lot of equations we got too. If you don't mind, you can try to post the equations. Even if they're not in English, I can usually read the math and figure out what things are. But it's up to you. Oh, and instead of dv, I could have said d squared x dt squared, or, 2. Okay, so, oh wait, velocity squared. Interesting. So I misremembered it slightly, I guess. Let's see what equations are getting posted here. Ooh. Let me make this bigger. Oh yeah, here's the hyperbolic functions. Hyperbolic trig functions. Okay. See any translation for something? Sounds good. So yeah, Newton's second law here. Oops. This is an image, so I can't highlight, but ma is equal to, the total force is equal to the force due to gravity minus the force due to air resistance. I don't know what each of these factors means, but it's maybe not too important yet. Hey, Storm. I'm good. How about you? We're also going to question from Beffy on setting up a differential equation to model freefall with air resistance. So I'm just trying to go through like what they've been given before I try to answer their question a bit more. And so yeah, we divide out m, but I guess a factor of m ends up there. Okay. And how are you doing, Storm? We have v sub t 0 equals 0. Okay. This is the solution that you get with hyperbolic tangent. And is that an identity? Or no, we're just defining... Is that v sub infinity? Not sure what that little like subscript is, but it looks like somehow this is equal to v sub infinity and this is equal to g over... Oh, okay, I think I see it. Hey, Jed. Okay, so we're just dividing this to be a constant and then putting this in terms of that constant. Okay. It is infinity? Okay, that's a... I haven't seen a subscript like that in this context before, but... No, I guess I don't know why you can't do it. So this feels like it's your answer already, so... The precise English word, some kind of test we're doing, drop the muffin cup, some graphs. Oh, okay. For the speed following x-axis? Okay. You try to solve differential equations or to find... So let me bring back up the question as Beppy posed it. You must have a differential equation that describes the speed of a body falling vertically in the gravitational field under the influence of air resistance. So that music was the universal language, never took math. Determine a solution for v of t. Actually, I can copy paste this into chat too. Experimentally investigate the equation of motion v of t necessary for Uppington. Determine value for the shape factor of the body. Okay, so it looks like you've done some practical testing here with measuring the actual velocity of a muffin tin or cupcake tin. And it's more about marrying those results to the math that's been done here. It looks like they have quadratic because they have a v squared factor here in the work that Effie posted. It's probably a little bit hard to read too on stream. So yeah, Beppy, I'd say that like this is basically you probably maybe you can plug in some values for the constants here, but like this is your differential equation and that's the solution to it. Or I guess you know that if you want to say that. I'm not sure like the A, and I don't even know what the symbol is, but like weird E or backwards G. It's more physics than math. Yeah, it sounds like it. Like, could one of those two symbols be our shape factor, or do these mean something else? Or C sub W, I guess, because I don't know what that is either. Maybe that's the terminal velocity. That's a complete shot in the dark, though. I doubt it is. And then you integrate it to get S of t. So yeah, I think these are looks like you're given the general solutions for your question already, which is great, so we don't have to work that out. So I guess like, what part of the question are you actually like trying to do here? Yeah, I guess if it's, I mean, for this, you could do separation of variables. And that's where your hyperbolic tangent could come from, I guess. It says use 8 to rewrite 1 and then show 12. So use 8 to rewrite. Oh, shoot. We don't have 1 pictured. All right, Thunder. See ya. Are you still... Oh, shoot. About your part B question, I can try to get back to you. I can send you... I can get back to you on Discord if you still need help with it. So I got completely distracted. I'm still not sure where to go with it, but... If you still need help with part B, I can try and figure it out and get back to you. It's fine? Okay. Up to you. So, Beffy, what was 1 then? Show 12. What are we trying to show? You kind of gave up? Okay. I'll still try to work on it. Oh, I see. Oh, this is, okay. This is the actual problem sheet here. Thank you for the follow, Ninek? Nanek? How do we say that? Koshi Lipschitz. So I think this is the actual question that they have to do. So maybe we're not even on the differential equation part yet. We just have to show that, oh, 11, not 1. So we just, okay. So then 8 is the exponential definition of hyperbolic tangent. 11 is this function here, which looks like the general solution to the freefall. Okay, okay. I think I understand what's happening here. I think. Okay. So let me write down the identity here first, what equation 8 is. Hyperbolic tangent of x is e to the x minus e to the minus x over 2. Oh, not over 2. I forgot. That's for caution cinch. E to the x plus e to the minus x. There we go. me put it back here. And to rewrite 11, so we need to show using this. We need to rewrite this in its derivative. Basically, define the derivative of 11 here. Okay. So I guess let's follow the instructions and say that hyperbolic tangent is the same thing as this, except we have this kind of ugly thing in the middle. It's okay though. It should be. Okay. So Beppy, I hope you're with me so far. All I've done is I've rewritten f of x with the exponential version of hyperbolic tangent. And at this point, I think we take the derivative. And that's the goal of this problem. Now, this looks horrible. You have to quotient rule this, I guess? I don't know if there's a simpler thing that we can do here. Hyperbolic tangent prime is equal to y prime over 1 minus y squared? Oh, really? I guess we're gonna get some cancellations. I don't know if we're supposed to like use like that shortcut though. Let me just, I guess let's just do the quotient rule and hope for the best. Because I don't know like what they're allowed to use. If they're, from what you're saying, Storm, it looks like we'll get some nice cancellations, but I don't know if we can just like skip straight to that step and that in Beffy's professor would like it. So derive the numerator first for quotient rule. So that derives to b e to the b x minus x0, right? It seems right. Plus b e to the minus b x0. Oh god. Times the denominator, not derived. Okay, this is ugly. I knew it would be ugly. I didn't think it'd be this ugly. Minus. Now you derive the denominator. Comes derivative composed function. They say specifically to use this exponential thing though, so I don't know what else we're supposed to do. Let's just hope that we can get some kind of thing that we can factor out or something. So we derive the, well, actually, I'll rewrite the numerator as it is. And then we'll derive the denominator. This is all on one line. This isn't... I don't think mankind has made a whiteboard big enough for this problem. I guess the problem is I'm doing it. Now derive the denominator. Minus b e to the minus b x minus x all over the denominator squared. I do expect there to be some kind of cancellation. That. Okay. This should be minus B. So, ooh. Like, this is the same thing as that. That's the same thing as that, but they're just... Actually, wait, yeah. They are if you just factor out the B. Okay, so maybe... Okay. Oh, wait, I need to make some arrow spaghetti. Come up here. Factor a B out from this? Squared. Because we have that with the B factored out times that. Then we do the same thing for the second term. Like that. Now, what are we expecting to get here? I think it's going to inform our next step. Oh, good. I think this is going to work out. Okay, there's actually like only one or two more steps. Okay, so what I'm going to do is I'm going to break up this massive fraction into two different parts because we have a minus in the numerator. So it can be this part divided by that minus this part divided by that. And I don't want to rewrite everything here, but this is the same thing as that. Like we have like this entire thing squared is the same thing as that entire thing squared. So we get a cancellation. Let me actually, in red, I'll try and show it. So we still have the B there though. We still have AB, which is from, oh God, I should have spaced this out better. Black pen, red pen. A, B comes from that part. Minus, I'm going to bring the A over. A and the B can come in front, times that over that. Over that original thing. Okay, and that we have to recognize as hyperbolic tangent squared, I think. Which, oh yeah, actually I have it written right here. Okay. And so that blue part comes from there. Oh, that must be Zach. Zach, thank you for the raid. Welcome in, everyone. I'm getting a workout in. Thank you, Jed, for doing that. Yeah. I'm remember this problem that I got from Beppy in chat involving except it's cash only. Yeah. There's 3 possible GIFs or GIFs, and it'll choose a random one each time. I want to add more, but I need to think of more. Yeah, thank you. The real announcement part of the stream was great. I'm gonna work on those questions probably at some point. And yeah, there's another multi-Python one that I wanted to, but it didn't work out too well, or like it didn't actually like show up well as an alert. It's from Life of Brian, where like the whole crowd is like, we're all individuals. I'm not doing a good impression of it, but it was a funny one too, but it didn't work out as an alert. But I want more like Monty Python. Anyway, before I get too distracted, I'm almost at the end of this problem, so let me finish it up for Beppy, so I don't continue to make them wait. But we're almost at the end goal here, which is we have to recognize this entire thing is hyperbolic tangent squared with an argument. And at the same time, we can factor out an AB here. So 1 minus, because that AB becomes 1. Hyperbolic tangent squared of b times x minus x naught. Yeah. And remember, that was our f prime x, which was 12. Okay. Dr. Gold, it's just a flesh wound. Okay, so Beppy, if you're still with me, I know that's a whole mess of algebra, but does that make sense? Doesn't quote the maidens of the castle anthrax. 40%? Okay. I'll take it, but no. As part of what you want me to explain more, please let me know. If you're not following the actual steps, the idea is really, I think the idea of the problem is you rewrite hyperbolic tangent with the exponential, and then you do quotient rule to take the derivative, and it's a huge mess, but you get some nice cancellations that let you boil it back down to hyperbolic tangent squared. So that's like the, I guess, key takeaway that I'd want for you to have from this, and maybe at some point it might be helpful for you to like go through it for yourself. So it's when you start differentiating. Yeah, there might be a language barrier too, but this step here was quotient rule, and now she like write it out. But yeah, well, what I would say is the most important for you to know is just like the general steps of how you do it, even if every last step you're not quite sure of. So Becky, I assume you're going to need help with, or you're also going to ask about like the rest of the worksheet too that you have here. I want to say, was there anyone else who was waiting for a question? It's like I'm not sure if Unga is still here, but they did ask a question I wasn't quite sure how to do, which are getting the complex solutions to this x minus 1 to the fourth equals x plus 1 to the fourth. I have like half of an idea for how you do it, but I'm not really sure. Because taking roots of complex numbers, I'm not that comfortable doing. Put z, oh. Hey, Anarkin. This is also one of your math projects. Oh, with the like differential equation with errors and stuff. Well, that's awesome. It's possible to come back to this anytime. Yeah, I mean, I'm not that familiar with the actual math, but like the way that Defi has set it up for me is really helpful for me, where I can figure it out as I'm going, where they provided kind of like their text and what their like context is. So if you provide me with that same type of thing, I'm sure I can work out what the math is, as long as we're on the same like level of difficulty. But yeah, if you'd like to ask me about it, please do. You can always type a question in chat or put it in my Discord. But yeah. Oh, and thanks for the follow. If you're interested in more math streamers in general too, because I'm sure there's others who'd be able to, I think almost everyone on this list will be able to answer a question like this. There's a whole list of pretty good math streamers there. They don't have actual education in there, so let me do a separate shout out there. And then Storm, you're saying, say z equals x minus 1 over x plus 1, and then say z equals re to the I theta. Okay, let me try working that out. I don't think that Unga is still here. Gone around an hour. Oh, nice. But I also will work through the question, and maybe they'll happen to check back on the VOD or something. I don't think YouTube has a whisper system, unfortunately, as far as I can tell. I don't actually know. I was assuming it's... See, I was assuming it's German, but I don't think German has the weird O thing. So maybe it's like... Or maybe it does. I don't know. I'm not cultured. It's Danish. Okay. So Beppy, do you want to see the other problems down here too? Like number 2, or do you feel like you have it now, or like do you want to see like any of the others? Do you have time? Sure. Okay. Let me take a little break and see if I can work through what Storm is saying to do for that little complex variable one, because I hope that wouldn't be too long of a question. Feel like a Danish dude, me too. So I'm taking a little break from your worksheet, Beppy, and then I'll come back to it, because I don't think anyone else is asking a question. So Storm, I might need to hold my hand a bit more here. But I think I understand kind of how you're setting things up. Ugh. So we have x minus 1 to the fourth is equal to x plus 1 to the fourth. And so what Storm is saying is to set z equal to x minus 1. Oh, not to the fourth, just x minus 1 over x plus 1, and put z in polar form RE to the I theta. Okay, I did that much right. Fourth roots are just one negative one I negative I. So, that's where I'm starting to get lost. I can see, like, would you raise each side of this to the power of 4, or is this already equal to the fourth root? This is the part of, like, complex variables where I show this. I don't know, like, what you do with x. Raise to the power of 4, it's equal to 1. Really? SPQ, I think it's just, there's like 4 different solutions, like 1, negative 1, I, and negative I. Oh, hyperbolic tangency. I think what Sorb said is the right final answer. You raise to the power of 4, it'll be equal to 1. So, I mean, like, do you raise this last equation to the power of 4? Okay. And then that raised to the power of 4. I don't know if this is what you're even supposed to do here, but... yeah, I don't know. I don't know how you draw a conclusion from that, to be honest. Equals 1. Why is that equal to 1? Like, this equals 1? Oh, from the first line. Okay. Oh. In the 4 ways you get positive 1 when you raise something to the power of 4 is 1, negative 1, I, and negative I. I hope. Because 1 to the 4th is 1, negative 1 to the 4th is 1, I to the 4th I think is 1, and negative I to the 4th should also be 1. Okay. Okay, thank you for that storm. That's value for all z, now isolate x. Oh, wait, we're not done yet. Okay. So do we have to do cases like when z equals 1? Or wait. It's value for z, now isolate x. So we say like 1 equals x minus 1 over x plus 1 and solve for x? Don't the x's cancel here? Four cases, yes. I feel like I must be doing something wrong. So you multiply each side by x plus 1. You get x plus 1 equals x minus 1, but the x's cancel. Oh, because 1 equals Does that mean 1 is not a solution then? Or z equals 1 isn't a solution? Okay. Oh, okay. OSPQ. Oh, okay. Okay. So if we do z equals -1, -1 is equal to x minus 1 over x plus 1, and I bet this will... Actually, maybe it won't. Oh, no, it won't. So here the x's don't cancel. You get, what, 2x equals 0? X equals 0? Okay, yeah, and I just knew by looking at it that x equals 0 will be a solution. Okay. Interesting. Z equals I. I is equal to x minus 1 over x plus 1. Ugh. Oh, hey. Oh, I don't know if Anakin, thanks for the follow. I don't remember if I thanked you. And then, Hermit doing lines. Thank you for the follow with the legendary name. Ix plus I is equal to x minus 1. I guess let's get the x's on one side, the i's on the other. X, I minus 1. I should do -1 plus I, but who cares? Is equal to -1 plus I. X. Oh, hey, and then those cancel, become -1. No, +1. Oops. Okay. And then I'm expecting the last one to be -1. It's +1. Negative ix minus I. X minus 1. X minus 1 minus I is equal to -1 plus I. Say x equals -1 is not a solution. Oh, well, x equals -1. Oh, you're right. It's not a solution. Okay. Is this just a number? I thought we were supposed to get some kind of cancellation. I feel like I got a sign wrong. But wait, x equals 1 isn't the solution. You get 0 equals 2 to the 4th? So I did something wrong? Wait, I thought the solutions were like 0i and -I. Hey! Since we divided by x plus 1. Okay. 0 equals 16 all day, every day. Exactly. What the heck is with this problem? I want to look at a Wolfram Alpha again. So I think the answer is supposed to be, like, if you plug x equals 1 back into this, it doesn't work. Don't worry. Oh, okay, Storm. Okay, so then this last one is just what I was... I'm making sure I didn't get a sign wrong. Subtract the x over minus ix minus x. Yeah, I guess you just get a weird number here. I don't think I messed up a sign. I thought there would have to be some kind of cancellation there. Just look at all possible values of z, but all the values are not right? Okay. Okay, so I guess my last one is 1 minus I over 1 plus I, if I make the signs a bit easier. X equals 0? Well, that's the real solution, Jed, but it's also complex solutions. I guess that's what the question was from the person who asked it on YouTube. So what do I do now, Storm, I guess? Yeah, I minus I and 0. Okay. Yeah, that's what Wolfram Alpha said. I'm a little confused how this leads to it, besides the x equals 0. Because I would have had to get x equals I and x equals minus I for these last two cases. Although I might be misunderstanding something here. One minus I over 1 plus I. Okay, yes, so we agree on that last case. Or I get the same thing as you just typed there. But I assume you can simplify. Oh, if you rationalize the denominator? Okay. I forgot that you can do that with complex number fractions. One minus 2i minus 1 over 1 plus 1 is equal to minus I. Okay, that's where the minus I comes from. Oh, or to use the exponential definition, I guess. I'm right? Okay. So where does the I solution come from? I guess we've gotten 0 and negative I. We haven't obtained positive I, unless that's what you have in your thing. Where somehow that is also equal to plus I. Z equals I, we had the mistake. Okay, maybe. -1. Oh, that should be -1 minus I, right? And now you have to do the same thing. Okay, I guess that's it. One plus I over one minus I. And I think that's just going to turn out to be I. Okay. I mean, I'm not going to actually check it, but I'm like 99% sure that it'll be positive I. Okay. All right. Thank you for the help on that storm. I don't know if YouTube actually has like a message system, but I'll try and get back to this person. And tell them that we worked it out. You use similar exercise, but more difficult. If you want, you can post it, but I think I want to go back to doing Beffy's questions because Beffy actually needed help with this differential equation stuff, I think. I don't reflect reality either. Okay. Speak you. All right, so you did this the hard way? So you're about to post something, Jed? Oh, I see. You messaged me. Oh, yeah, you factored everything out? I thought you'd get too many cancellations for this to work. Oh, I guess it's okay. I thought about doing this, but then I thought too many things would cancel, but I guess not. That's the way that I would understand how to do this, I guess. I would not have thought of the thing that Storm did. Just the even exponents cancel? Oh, okay. I'm sure you can explain that with the binomial theorem. Okay. So... Oh, you know, I think problem 2 here is going to be fairly... It's going to be way less steps than on problem 2, or problem 1 at least. And thank you very much for the help on that, Storm. I appreciate it. Complex numbers are fun, but I don't get them. Gotta wait for Pensons to do that complex analysis class, I guess. Hopefully. Actually, I even have a book on complex numbers. I just need to actually read it. Term as an even exponent on x, then you multiply the constant even number of times. Oh, okay. I guess it makes sense. So we have that f. Oh my god, that I couldn't decide if I wanted to make that in apostrophe or parentheses, so I went with both. F prime x is equal to AB1 minus hyperbolic tangent squared bx minus x0. And we want to show... Actually, let me write down f of x too. A hyperbolic tan B minus x 0. Okay. So we basically want to, we notice we have a hyperbolic tangent in f of x, and we want to use our definition of f of x in f prime of x for whatever reason. I don't know why, but we certainly can. Let me actually show this in a different way. Okay. Show that you will arrive to the differential equation. Oh, okay, Storm. That makes sense. I can see, or I can like. I guess that makes sense. So. I'm trying to work out the b over a. Oh, let's multiply the AB in. That'll make it a bit more clear. So basically, we need to notice that this little thing here is nearly the same as f of x. But we have a squared that we need to deal with, and we have AB when we want just A. So we can make... Let me actually do it like this. To match f of x. And then in red, we have, it's like f of x, but squared. So when we come down here to basically compensate for how it's different, minus, so we have AB, we want just A. To fit our kind of definition of f of x. So we can say it's b over a. Actually, wait. Is that actually... Are we missing an a if we do that? I'm thinking about this the wrong way, aren't I? I know, I like, doesn't the a just go away? Isn't it just b times f of x squared? Why is the over a here? Oh, because I get it. Okay. Because the a gets squared as well. Okay. So because we have to say f of x squared here, I forgot that the a would also get squared, which is why we have to do this. F squared x. You know what? Maybe the way to make me not get mixed up here is to actually write out f squared x. Because what it's going to turn out is that this a also becomes squared. B over a, because a squared times b over a gives you just ab. That's why you're able to say this step. Okay. You're always here? Okay, sounds good, Beffy. All right, so I hope that explanation wasn't too all over the place for you, but I think that's how you're supposed to work out problem 2 here. And so for any of these, oops, let me show what I'm looking at. F squared, you're lost. Okay. So we're basically trying to make the point that we have a hidden f function inside of our derivative because we notice that we have a tangent, a hyperbolic tangent here and a hyperbolic tangent there. But the issue is that in the derivative, it's hyperbolic tangent squared. And if we want to substitute in f of x, we also need this hyperbolic tangent to be squared. The title 2.3, it's like the letters were written randomly. Yeah, it does seem like it. And so I worked out what f squared x is to make the hyperbolic tangents match. Okay, cool. And then yeah, and then you get the a squared here, so you have to do whatever it takes to compensate to get you back to ab. So b over a times the a squared will get you back to ab. And that's the part that I was getting tripped up on. Yeah, like these letters here, yeah, they look random to me too. I guess that's Danish. Okay. And it looks like the random letters down in 2.3, as we've been calling them. It looks like we're kind of proving some identities here, at least for 2.4 on. What's question 3? Is that something that you'd want to see as well? 3, 13, and 4. This is 13. 3. Oh, this is getting to actually solving the differential equation, maybe. Derivative of. Okay, yeah. So, is it just showing that equation 13 matches the form of equation 3? Basically, Storm called it, that this is where the problem was going. Math and physics task. Like, what does the actual problem 3 say? Like I assume it's like using 3 show 13 or something like that. Take the good b and you'll solve 3. Oh, okay, Bevy. Use 3 and 13 to show 4. Nice, Danish, you got that. I was just guessing from the direction of the problem, but I'll take it. Use 3 and 13 to show 4. Okay. Yeah, Storm. I I think you're right here. It's all about your choice of A's and B's. Okay, so Let's get 13 back up on the board, I guess. Maybe I shouldn't have erased it. They really give all the stuff. It is not fun. Oh, is it going to be complicated to solve this? Okay, this is the weird E thing. I'm just going to draw it as an E because I don't know what it's supposed to be. Oh God. Okay, and then man, we have to use 4 to cook a cake and follow the orders. Okay, yeah. I mean, I'm sure that's a good way to like say it, but it's gonna be annoying to follow it through. Two GM for weird E A C sub W. Hyperbolic tangent. Root. Weird E G A C. Weird E G A C. 2M. That's not a 2. T minus T sub 0. And that was equation 4. Okay. And so we have to use 3 and 13 to show 4. Use these first 2 to show 4. So, yeah, I guess we have to match the actual terms here. So f prime x is our dv dt, f squared x is our v squared. So that means AB is G. And B over A is that. How is this possible? Wait, if AB is G, why isn't there a G involved in the other one? Do not use 4, you want to show 4. Yes. We're using the first 2, we're using 3 and 13 to show 4. It is not the same A? It's rho? Oh, that's not rho how I'm used to it. That's interesting. Because for me, we always showed rho as like a P. Oh, it's just like a really curled around rho, I guess. Huh. I haven't seen it written like that. Okay. That's good to know. Thank you for telling me. It isn't the same A. I feel like it should be the same A, though. Oh, or maybe it's not rho? Either way, I just know it's a symbol, so it's not like that important. I don't know how these are possibly true unless there's some kind of relationship between G and the others. Show the PDF? Yeah, sure. If you want to see a different page, then let me know. Varro. Oh, okay. Three. Oh, there is that A. Are those the same A? I guess they would be. Maybe that's how it's possible. Or it's just not the same A. Oh, you're right. It's not the same A. Yeah, it can't be. Oh, that's really annoying. Okay. Yeah. You're right, Storm. Okay, so what Storm pointed out is that they use A over here in the formula, but then in a completely separate context, they use A over here in this generic version, but these are not the same A. Okay. So in the generic, yeah, we'll keep the A for the variable, and then I'm going to change these to be B and, or maybe I should make them both different. Like I'll make them D and E just so B doesn't get confused either. Well, because if I use B again, then it's going to be confusing as well. I'll say A equals D, B equals E. Well, why not use C? C and D. Dude, this is so confusing with the letters. Then it was B over A. So D over C. Okay. K and C? Oh, that works too. Give a name to the fraction? Like make this a new letter? Actually, wait, don't we have the exact same issue where where does this G come from? It will be Meyer Beautiful? Okay, so just say Z is equal? Okay. I'm just following Storm. More beautiful? Okay, okay. So I guess we're giving this part a new name. Now solve the system. CD equals G. Okay. CD equals G and D over C equals Z. I guess let's say that D equals CZ and plug it in up here. C times CZ equals G. C equals root G over Z. I guess plus or minus, I'll just take the plus. I don't know if that's important. Plus or minus? Okay. We'll keep the plus or minus. And then we can solve for D. If C equals that, I mean, I guess that neither of them are that convenient to use. Well, D is equal to C times Z. So if I just say D is equal to C is plus or minus G over Z times Z. That's Z over root Z. Which is, if you rationalize that, that's just root Z. So plus or minus root GZ. You must choose after? Okay. Okay, and so remembering that Z is just this very complicated fraction, the plus goes with the plus, the minus goes with the minus. For the C's and D's, like they have to be paired like that. Royal Mai, welcome in. It's a little bit hard to explain because like this is like part of a worksheet that we've been like working through. But basically the task is use equations 3 and 13 to show equation 4 and kind of like basically work out what these constants are supposed to be in order to like match. You must be sure that Z is greater than 0. Well, I don't know what all these constants mean. The math should always be positive. I've gotten that far. I don't know what any of what row A or C sub W are though. We suppose z greater than 0. Just have to choose the good sign. Well, I guess maybe we can work that out from how the number's actually written. That's where a test starts to confuse us. For getting the right sign? I thought we'd be able to tell from... Oh, actually, I guess I don't know. No matter what... Actually, maybe the sign is irrelevant, because either you have to both take plus or you both take minus. And C and D are always multiplied or divided, so the minus goes away. I think you can choose either pair, and it turns out to be the same thing. Use the physics vision. F represent what? Speed. Yeah. F greater than 0. Yeah, we're not expecting to like have negative velocity, yeah. Because we were just talking about free fall. It's not going to suddenly start going upwards. Then take plus. Yeah, I mean, honestly, I think either way you're okay, because either you take both of these as positive, or you take both of them as negative, and see if it's a negative times a negative, it's positive, and it's a negative divided by a negative, it's still positive. So I think either way you're okay, honestly. Unless I'm misinterpreting something, but I don't think the choice is actually relevant, the way that I'm looking at it. Or either way, it leads to the same end result. You took the wrong line? Definition of F, not the differential equation. But this is C times D, isn't it? Oh no, you're right, you're right. My bad. Oh yeah, because this A here is on its own. So never mind. I was completely wrong with my logic. But I think I assume you still want this to be positive because you're expecting the function to be positive. We can look through and see if they give us that f is supposed to be greater than 0 or v. Royal Knight, thank you for the follow. Sorry, I'm not doing a good job of explaining what this exercise is. It's kind of hard to... it's kind of hard to explain it, I guess. Oh, positive variable. Thank you for the follow. And actually, that's a very relevant username because we're talking about positive, negative variables right now. You will not go to the top. Yeah, I think you can safely take the positive ones. Still looks fun? Okay, good. Glad to hear it. Okay, so Effie, are you good with what we've said so far, I guess? I know that we've been going back and forth a lot. And that I've not been doing a very good job of explaining things, but how are you feeling right now? It's just out of curiosity. I want to see if that's just an alternate way of row. Even this one, the Z part is a bit confusing. So you don't like physics, you would go to the top with negative velocity. Oh yeah, so that was just like a little simplification that Storm suggested, because this fraction is just a giant pain to write out every time. So instead of doing the entire fraction, we just give it a name Z, just for the sake of doing this like math down here. So everywhere we see Z down here, just imagine this giant ugly fraction. We just didn't want to repeatedly write this entire thing. So technically you should say that and the A's and B's are getting confusing here too. Oh, okay, or if you understand it. In the like original thing, I'll just like still explain it just to be safe. F of x is equal to a hyperbolic tangent b x minus x0. We said that a is c confusingly, and so we got that c was that root g. It's g over that thing. And of course, you could like simplify that fraction a bit more. And then b is what I said was d, which is g times that fraction. So that's like maybe the final step that I like left off there, but that's what we just like worked out basically. We gave things some different names because I don't think they're using very good letters there, but oh, because yeah, I think it's just an alternate way to write row. It's kind of interesting because it's just called var row, so like variation of row. I was like curious to see because I've never seen it written like that. Either way, it's just a letter, so it's not important. We could draw a fish there if we wanted. Yeah, that's a whole mess of letters, but I guess the math works. It looks like after this with 2.4, it's just kind of proving identities, which I think you would do using the exponential form. Finishes proof with the usual box. Oh, you know, I guess we did the work, so may as well put a box. There we go. Okay, so I think these last two that I can actually see, I mean, I guess 6 is a little bit cut off, but I think 4 and 5 would be pretty quick if you just use the exponential definitions here. Would you want to see these two, Beffy, or... Oh no, I forgot, my phone died. Ah. Let me see if I can get it charged quick. I want to keep going. I'm feeling mathy. Sorry, I used my phone for my big camera, and my phone just died because I forgot to put it on the charger when I started the stream. Oh, Storm, thanks for following. Um, you know, if it's not too late at night for you, Storm, you got time. Okay. So I'm still curious about Storm's other like complex variable problem, but if you want to see these two, I can go through them because I don't think they'll be particularly long. While my phone gets a chance to charge, I guess I'm going to use Paint. Oh no, Storm, like earlier you mentioned a different problem that was like the x minus 1 to the fourth equals x plus 1 to the fourth. I'm kind of curious to see what that is if you still happen to have it. But if not, or if it's too late at night for you to want to like explain it to me, then I completely understand. Just do it whenever it fits. I think I can do this relatively quick here. It was a problem. You said it was. If you don't remember, it's completely fine. I was just kind of curious if you still happen to remember it. When we did that problem there, you said that there's like a similar one that was a little bit harder. I'm kind of like curious about it, if you still remember it. But if it's too late at night or whatever, I don't mind. Because I think these problems here are just going to be a couple of steps. So we want to prove that hyperbolic tangent is hyperbolic sine over hyperbolic cosine. And I think we want to go to the exponential definition here. So let's work on the right-hand side and get hyperbolic sine and hyperbolic cosine, which I need to Google. Actually, does your sheet thing provide that? It does. Okay, good. So I'll put hyperbolic sine in red. E to the x minus e to the minus x over 2. Go back to black, over, and then we'll do hyperbolic cosine in green. E to the x minus e to the minus x over 2. So that's where each of these parts of the fraction comes from. Now we want to take the, oops, wait. I need a plus right there. Now we multiply by the reciprocal of the bottom. So we get e to the x minus e to the minus x over 2 times 2 over e to the x plus e to the minus x. Where that, just goes over there. The 2's here are going to cancel, so we just get e to the x minus e to the minus x over e to the x plus e to the minus x. And that is just the definition of hyperbolic tangent. So I think that's all you have to do for this problem. So is that good with you, Beppy? For that one? N belongs to n, solve z minus I to the 2n plus 1 equals z to the z plus I. Okay. Oh gosh, okay. Let's work through these last two problems from Beffy. So let's do cosh prime is equal to sinh. So here we just want to take it to exponential again. So cosh and exponential is I literally just said it and I forgot. E to the x plus e to the minus x over 2. Now we want, oops, prime. Now we need to derive this. E to the x derives to e to the x. E to the minus x derives to minus e to the minus x because of chain rule. And the over 2 stays where it is. And then right here, wouldn't you know it? This is the exponential definition of hyperbolic sine, or sinh, as at least I was taught to say. I don't know how widely said that is. So Those two only required a few steps. Oh, I guess you could do the series too, Storm. I feel like hopefully you wouldn't have to do series though. And then this was the third one that was posted. It's a little bit cut off for me. 14 and 15. Hey, Felix. Yeah. Just to share with you this beautiful formula. Oh, okay. Pen Center, thank you so much for the 4 months. I appreciate you. Been doing some hyperbolic trig in Danish, you know, just 'cause I wanted the extra challenge. This one I might need some help translating though, Beffy. Stuff for 18-year-olds? Oh gosh. I didn't learn this stuff at 18. 14 and 15. What were 14 and 15? Oh, okay, what we just did was 14 and 15. Differentiation of log of x. Something about equation 6. Oh. Oh. This is 14, 15 with the rules of differentiation for log x to... okay. Thank you, Felix. S is V prime. S is position, Storm, I think. Or no, sorry. Integral. Sorry. Because V prime is acceleration. So S prime is equal to V. S is position, V is velocity. So they're saying these 14 and 15 together with the rules of differentiation for log x. Yeah. You put the funk in stead function in Pen Center. So I think we derive 6 and show that we get 5. Or do we integrate 5 and show we get 6? They say rules of differentiation for log x. Wait, no, I'm getting my derivatives reversed again. You integrate v or you derive s. You'll die with a fraction. Yeah, it's from FER6 in chat. The person who thanked you. These all have to do with modeling an object in Freefall with air resistance. Um, 14 and 15 with the rules of differentiation to show 6. It is clear you have to integrate v? Okay. They say the rules of differentiation. Okay. Oh, that's where you're saying the U sub can come in. Okay, okay. How can I... Maybe I'll do it like that. Just to keep the equations up here. Okay. Oh, so okay, maybe it won't be that bad because of what Storm is saying. So we do have to figure out. Okay, so we can actually use the so equation 5, they give us what the constant should be. V sub infinity. Hyperbolic tangent. G over V sub infinity. T minus T sub 0. Okay. Yeah, I'll just use like the convention that the worksheet uses. So we integrate velocity to get position, which apparently I can't keep straight in my head. V sub infinity. Okay. And then, as Storm said, I guess the V sub infinity is a constant. We write this as sinh over cosh. And then, okay, yeah, so this integral is really not that bad. It just looks like a mess. So from here, we have a convenient use of that Storm is pointing out, which is u equals cosh. My infinities are going to get gradually messier throughout the problem, and that's just how it's going to be. We show the derivative of cosh is sinh. Oh, we need to do chain rule, though. G over V sub infinity. Sinh G over V sub infinity T minus T0 dt. Okay, so V sub infinity times the integral. Now with the chain rule, the cinches are going to cancel. We divide by G over V sub infinity, which becomes V sub infinity over G times 1 over U du. Okay. So V sub infinity squared over G are both, these are all constants, so they can come out. And then we get times ln U. Do we have to write the constant of integration here? Probably. But it's going to turn out to be 0, I bet. Because we're given that V T sub 0 is 0. But let's still write it and just be correct. We can unsub now, because U is equal to cosh. Plus C. Okay. Cosh is always positive. That's something I was debating in my head because there's the upper and lower part. But yeah, I think when it's just cosh like this, it's always the upper part. So I'm on board with that. So we can turn the absolute values just in parentheses because cosh is always positive. And now we need to deal with the plus C, I think. We're given, oh wait, oops. Oh, and we're given V of T sub 0, 0. We're given S? Yes. S of T sub 0 is equal to S sub 0. That's the initial condition that we're given. Storm, yeah, exactly. Storm's a hero. S of T sub 0 ln the MIT integration piece, probably. So cosh of 0 is just 1, I think. Let me look at the exponential. Yeah, cosh of 0 is 1. Okay. Hey, just like cosine. You actually did in high school? And ln of 1 is 0, so c equals s sub 0, conveniently. So we get s of t is equal to v sub infinity squared over g ln cosh g over v sub infinity t minus t sub 0 plus s sub 0. Does that match? If we, well, okay, well, I use the v sub infinity, but I think it matches. Okay, that's awesome. Yeah, they say that v sub infinity, they don't actually say it, but it's implied from the step above here with equation 4. So I think it's more or less our C and D. Yeah. I guess we should show that step too. Okay, Storm. Well, let me back up. V sub infinity, it's just whatever's in front. It's root 2gm rho, oh god, rho AC. Yeah. So then S of t is equal to, the square root goes away, the g cancels, so 2m over rho AC sub w ln cosh g over that. Does the g just go to the denominator? No. It's like g over root g, which is just root g, so the g stays in the numerator. And that matches what equation 4 has. Okay, there. That's the final answer. Square or box. Gotta put that. All right. So yeah, Becky, I hope that helps. And if we lost you on a step, please let us know. It, like, the actual math here, I don't think is that hard. It's just so many symbols to keep track of. That makes it into a hard problem. Yeah, exactly what Felix said. It's a lot of algebra. Seems... Oh, you haven't learned about integration? Oh, that makes this a lot harder. Okay, yeah, this step with the U sub probably makes no sense to you. Hey, Penn Center. Most calculus is algebra? Dude, like, calculus is the ultimate algebra test. Well, I hope it wasn't the reverse direction where you are supposed to derive S to get V. Oh yeah, for black pen, red pen. Um, yeah, Black Pen Red Pen's channel's great. Let me drop a link. But yeah, I guess integration is really just the opposite of taking the derivative. Although sometimes you need to use some weird techniques like this hue stuff, which it's hard to just like explain on a problem that's complicated, but I still leave the problem there for now, and I want to look at storms kind of for fun problem. Oh yeah, it like a really nice looking like poster thing. By the way, where do they know the exact one? Coffee Beans, yeah, Pin Center. I just made that last night. While I was watching like Dan's stream or maybe Dr. Gold as well. I don't remember exactly one, but all right. So this was an interesting one that Storm was saying. Actually, I might be able to get the whiteboard cam back up. And Storm, if you're going to bed at any point, please don't stay up for me. Or like don't let me keep you. As a beautiful solution? Okay, you already in your bed? Okay. So let me just uncrop my browser and then I'm gonna hide it. You think and ask hint? Okay, yes. Well, I assume we're gonna do a similar thing as the problem that you helped me out with. Let me get my whiteboard cam back up and running. My phone's had a little bit to charge. Sorry, I just had to throw some mail away that I realized I just had right next to my camera like a dummy. Did I do the link wrong? Why is that not showing up? Oh, I did do the link wrong. There we go. Cam's here. Okay. Do you know when VOD will be available? Bethy, it should be up now. They're unpublished by default. And this is also on YouTube as well. So if for some reason Twitch isn't working, it'll be over my math YouTube channel as well. So whatever your preference is there. We copy down the problem. Property of complex exponential, but it's for the end. Okay. Okay. Verify z equals I is not verify z. Oh, because we want to divide by z plus I. Okay. So that's minus 2i to the 2n plus 1 is equal to 0. And there's no n such that this is true. So z is not equal to negative I. All right, see ya, Beffy. No worries. Thank you for the questions. Okay, awesome. So we can safely divide by z plus I. And I assume we're gonna do like z equals. That's not how you write that. Or not z, I guess w? I don't know. Name it t? Okay, we'll name it t. Okay. Now, we raise both sides to the 2n plus 1, or t equals r, okay. re to the I theta. I keep on writing that wrong. So this is the part that I was a little unsure of on the last one, where we raise each side to the 2n plus 1. Then I forget how we draw the conclusions from there. With r greater than 0, theta belongs to 0 to 2 pi. And I'll write it in the American way. Look at your third line. That's right. So re to the I theta to the 2n plus 1 is equal to 1. Perfect, okay. And so whenever I see like this, I want to use de Moivre's, but I don't think it's 1 is equal to Miles. Hey, how's it going? So to the I times 0? I can see why this on its own is true. But doesn't the R affect things? Module and argument are equal. R equals theta? Or no, no, yes. Is Dondo? I know they have like DDM or something, but yeah, I think you have to be a partner to customize it. There's worse ones though. It's like this step here is what I didn't quite understand about the last problem. R to the 2n plus 1 equals 1. Oh, okay. And 2n plus 1 theta. Oh, okay. In order for this to be true, mod 2 pi. Do we need the mod 2 pi if we're restricted to 0 to 2 pi? Now find r and theta. Okay. Well, I guess r and theta in terms of n, so log of r? Log base r of 1? That feels wrong. No, that's not how you solve for r, is it? One to the 1 over 2n plus 1? And then theta just equals 0. Well, n can't be negative. Am I getting mixed up? Use a tank? Oh, what's the simpler way? You have r times something equals 1 and r greater than 0. Then r equals 1. Okay. Yeah, no matter what you choose for n, r is just always 1. Theta, you're wrong. Okay. Well, n is a natural number. So I don't see what else it can be. One of these has to be 0, and 2n plus 1 can't be 0 as far as I can tell. Happened with the mod 2 pi. Oh wait, so I thought we didn't need the mod 2 pi because we're restricting theta. But I don't know what 0 mod 2 pi is, like... Because I'm really bad with modulus. Is it just 2 pi? What is 0 mod anything? I feel like it's always just whatever the mod is. Equals 2 pi k. Okay. And k could be 0. So I only found one of the solutions. One of it is 0 on 2 pi? Okay, yeah. So I don't know, is k any integer or is k an integer greater than 0? Then theta equals, oh, okay. 2 pi k over 2n plus 1. I guess. Oh, and then now we need to find all of k's such that we're between 0 and 2 pi? Well, that depends on n as well. Just keep all the K. Okay, yeah. Well, K equals 0 was definitely right. What else can it be? If K equals 1, I guess that is something less than 2 pi, no matter your choice of n. The thing is, n can be something really big. So you can choose a lot of k's here, potentially. More simply, you want k over 2n plus 1 less than 1. Oh, okay. That is more simple. And so k is less than 2n plus 1. And 2n plus 1 is always positive, so you don't like flip it. Okay. What are the possible values for t? Oh god, okay, so well, it feels like we have infinitely many. It's all diverges of e to the I theta. K is an integer, right? So, like, 0, 1, and 2 are always less than 2n plus 1, and negative k's. No matter what your choice of n. But how many integers are less than 2n plus 1? Well, I guess from negative infinity depends on n. That's where I'm struggling, but like guaranteed, k can be between negative infinity and 2. I guess if you want to rate it with your notation. No? Wait, I'm confused because n is anything. Theta greater than 0. So then that means we take k equals or greater than 0. So k equals 1 and 2? Zero, one, two. Okay, that's that makes sense. So I was wondering how you deal with the n. But then if you do have an n here, how do you make any like conclusion? Or like how do you deal with an arbitrary number of k's? Oh, negative k's just wouldn't be distinct. Okay, so back to t equals. Um, well, t is equal to re to the I theta. R is 1. E to the I, 2 pi k over 2n plus 1. I guess? Perfect? Okay. I'm glad I at least did one step right. Now isolate z. Oh, okay, with that. Isolate z. AC multiply each side by z plus I. Let's get z e that. Minus 1 minus I e to the I 2 pi k over 2n plus 1 over 1. No, no, I probably shouldn't be doing this much mental math. Things like that. Now the beautiful will arrive. Okay. Minus 1 is equal to e to the I pi. Okay. Oh, so, oh. Minus 1 minus, so e to the I pi is minus 1. Those other exponents stay there. 2k over 2n plus 1 over minus 1, 2k over 2n plus 1 minus 1. Oh gosh. Wait. E to the 2i pi, we should know? Yeah. Okay, Bob. Well, this is a completely separate problem, but yeah. Keep the exponential? Well, then what's the e to the I pi equals negative 1 thing for? Oh, you do change the negative 1. Okay. This apparently has a beautiful, like, answer, so... Oh, you shaved the stash too? I is equal to e to the I pi over 4. That I. Okay. Oh god, I should have made more room. All right, we're making some spaghetti. Ah, okay. Parkour. E to the I pi over 4. Okay. Okay. Do we combine the e's that are up top? Like I want to multiply those two e's. I think I'm gonna get yelled at though. Now simplification time? Okay, so maybe I was right. Just got thinking. Well, they all have e to the I pies, I guess. We just cancel the e to the I pies? Put your product in one exponential? Okay, okay. Let's not get off track from what Storm is telling me. That's dangerous. Okay, so you multiply the same bases, the exponents add, right? If this wasn't a million different symbols, I'm sure I wouldn't have to ask that question. Yeah, because 10 squared times 10 squared is 10 to the fourth. Well, that's not a good example. 10 squared times 10 cubed is 10 to the fifth. I think. I don't know. I feel like I messed up that basic thing, but let's just keep going with it. And I'll let someone yell at me if I did it wrong. Verify my last. Okay. The NZQRC for the types of numbers. There's like some Greek letters. There's some fancy normal alphabet letters. As far as I know, they're just fancy alphabet letters. Well, RG, you're really selling me on it. Oh, wait. SBQ was right. I think. What's the problem, RG? So I think we're getting towards the end of this complex variable one from Storm. Okay. There was a mistake? Okay. So SPQ, we should have done I equals e to the I pi over 2. But I don't know if there's a different mistake that I also made, which I would absolutely believe. The numerator, it's minus I instead of minus 1. Okay, Archie, I'll look at it after this. So you're saying that this I somewhere up here goes wrong? At the numerator, it is minus I instead of minus 1? Oh, wait. Oh, this one should be minus I. Oh, did I just wrote... I forgot to put the dot on that I, maybe. No? I forgot to put the dot on the I, dude. I seriously... Oh my god. I literally... Okay. My bad. Okay, so yeah, that should be minus I. Is that a 1 down there? Now I'm questioning everything. I feel like this one is potentially wrong. Oh wait, actually that might say as a negative. Wait, did I turn all the i's into ones? No, okay, so that is a 1 down there. This is an I up here. Okay. And minus I is equal to e to the minus I pi over 2. I guess we can do it on that minus I as well. Ugh, let me do them both in the same step. Okay. Right? I think that's right now. Never seen the best formula ever, which is for AB belongs to R, e to the IA plus e to the IB is equal to 2. Oh, wow. Okay. I need to see how this is gonna... Okay, so the numerator we have... Oops, sorry, shaking the camera. 2 cosine A minus B. Wait. A minus B over 2. Um... Oh my god. Times e to the I A plus B over 2. Ah! I'm running out of room here. my god, over. Minus 2i sine. Everything else is the same. Jeez, okay. I did a mistake. Oh, not again. You're right. I wasn't paying attention to that. What did I do wrong this time? I don't see what I did wrong, unless we want to make this e to the positive. Well, I would need to do it both with signs now. So wait, how I got both positives up there is, I think that both negatives here are right. So could we say positive, can we do like minus positive I and say minus e to the... Oh wait, I didn't do this right. Oh my god, I wrote the bottom completely wrong. No, I just copied down, wrote what I did on the top on the bottom, but that's all wrong. Because the A's and B's are different. It's A minus B. I just use the same A's and B's from the numerator. I don't know why I did that. A minus B over 2, A plus B over 2. But this should be 2i sine. Minus 2i sine, I guess. If I have both pluses here. Okay, I think that's matches my previous step at least. Factorize by minus I. I don't know what moment you said that at. Just like cancel the minus I from the top and bottom? But keep the 2 there? I feel like I did something horribly wrong still. Use what SPQ said. You'll go to sleep? All right, Storm. Thanks for trying with me. Sleep well. With hyperbolic cotangent. You just have to simplify it? All right, I'll try simplifying this, I guess, and just seeing if it goes anywhere, but... And then I'll try it SPQ. Actually, well, let me look at what SPQ is saying before I try to do... You get minus cotangent pi ik over 2n plus 1. Write the solution again. Okay. So yeah, I'm not following how you get to that cotangent spot. I guess it's something with the e's over the e's, but I'm just not following. Well, no, I'm not going to get cotangent with my way. I think I just did something horribly wrong. So I just get sine over sine. Well, no, but we can use an identity. Whatever the co-function identity, potentially. All right, let's just pursue this down a little bit and hope we can get a cotangent out of it. But if I don't get one soon, then I'm just gonna wait for SPQ, I guess. Okay. Minus pi over 2 plus pi over 2 goes to 0. So we get pi k 2n plus 1 e to the minus or e to the minus I. No. Pi k over 2n plus 1 minus pi over 2 e to the I pi k over 2n plus 1 plus pi over 2. Well, we expect that I feel we get some kind of cancellation with the e's, just not the exact one that I wanted. Sine minus pi over 2, does that just become cosine and that's the key here? I guess we get a tangent with that, but... Okay. Sine minus pi over 2. If you do sine of x minus pi over 2, that shifts it to the right, which is negative cosine. So I'm getting a tangent. I feel like that's wrong, but maybe we can turn it into the right answer. The e to the I pi k over 2n plus 1 business cancels. You get e to the minus I pi over 2 minus, so that's e to the minus I pi? Oh my god, and e to the minus I pi. We already said that's -1? Is that what we said? No, it's pot -1. I don't know. I think I did something horribly wrong. I'm kind of close, but not. I did something wrong. Or that nearly matches what SPQ said. Two n plus 1 roots of unity. Therefore, of the form okay, denoted z sub k. So not even worrying about using weird stuff with the e's, I guess. Just letting it all be z sub k. It's definitely a lot simpler. And I kept making mistakes doing it I guess, the hard way. Thank you very much, SPQ, for like spelling that out for me. Because I think these complex variable problems are interesting. I wish I knew them better. So it's kind of fun to get these little like... Oops. These little like lessons in it. Okay. Oh my god, I've been going for 4 hours. I still want to keep doing math. I'm not gonna make any promises about RG's problem here. Oh wait, I think RG deleted it. I don't see it anymore. One of those. I don't know. You end up just doing it. All right. That's fine, RG. Because I wasn't sure if there's some real analysis stuff that I want to do for Zach's class. Anyway, so I wasn't sure if I would want to do it. Okay. Before I switch over to real analysis stuff, let me see if I got... Okay. Nothing new on... No new, like, DMs on Reddit. So... let's look at what the real analysis has. We only went up to... we got up to number 3 during class today. And so... oh, so we were kind of talking about 4. I didn't even know that 4 was going to be this. Based on your ideas in the previous prompt, that can be said about all sequences. I do really have to use the bathroom. I leave the problem up in case someone else wants to look at it, but I'm gonna go and use the bathroom quick. I'll do you guys a favor. Oops. I'll do you guys a favor and leave my mic here so you don't have to hear me go to the bathroom. You have to pay extra to hear that. Okay, there we go. First command still works? Yep. Okay. So I need to remember what the heck we were talking about for part 3. I'm curious if Zach is going to rephrase his part 3, because there's definitely... Me and Obi are going back and forth about what it's even asking in the first place. So I have to wait and find out, though. Oh, and Jed, since you are here, let's test out a little something I added. There we go. I need to look back at the notes that we were taking on this one, I think. I should probably change the playlist too. I'm probably getting close to having looped back on it twice. Let me do that quick. Quick. Where's that lo-fi one that I was listening to the other day? Should have actually like hit favorite on it so I can come back to it easily. Lo-fi. Should be like the first one that shows up, right? Oh, come on. You know you want to show me it. Able to procure a new monster flavor, ginger brew. I mean, I think all energy drinks are really gross. That could be an interesting one, though. I'd never tasted an energy drink that I like, and I'd rather get my caffeine from somewhere else, so. Even I never had an actual energy drink to myself. I've only had the sip of like someone else's. Here's the one that I wanted. It'd be funny, Sticky. This entire time, you've just been like, you've been working for Monster, just trying to like sneakily advertise. Honestly, I would respect that. Not an ad. Okay. You're just pretending to like know math. You're really just here to get me drinking Monster. You know, I'll take a Monster sponsorship though, even though I just like trashed every energy drink company. Oh yes, okay, maybe before I get this deep into it. Oh god, what the hell, what did I, oh, I did that. We kind of glossed over a proof for part 2 that maybe I should actually look at more before I move on. For every energy drink sucks, except for the one that was sponsored. Exactly, Bob. I think for part, for 2, part D, actually proving that this, actually no. I think, no, it was for E. Proving this intersection is empty. So you can formulate it like a limit, or you know, like an epsilon n proof. But I understand the concept of it, but I still don't really understand the mechanics of it. So maybe let's try doing the mechanics. So our notes on it were over here. I'm gonna erase the whiteboard in the meantime. Get all these eyes off my screen, off my whiteboard. It's time for real analysis. None of that fake analysis stuff. Okay. So we're taking an infinite intersection, the set that's basically getting closer and closer to 1 from below. It sure is The World Death Note by Otaku. This place has a lot of anime on it, it seems, which I just more care about having something in the background, so. Increment to non. I've heard of it. I just like I've never had that much of an interest in watching anime. I'm sure there's some anime out there that I would like, but I feel like there's enough like live action shows that I'm more interested in that I'd rather watch. So this idea in text, oops, yeah, you can see my cursor. This idea in text is what I wrote. As my attempt to kind of like start a more formal proof. And I don't see why it wouldn't be valid, because your epsilon is still kind of any arbitrary number between 0 and 1. But in this context, I think that's fine. So it's just the exact same as the normal. I mean, let's go through and should still go through and do it though, right? I want to understand like every part of this problem, and I could hand wave and say that I understand this, but I don't feel like I don't actually understand it. And Obi did do this little stuff over here with finding what the choice of n would be. But let's do that part for ourselves too. Let's do blue. Actually, no, let's do green. We don't do green in that. Let's remind myself what h sub n is. N minus n, or n minus 1 over n, okay? Which is also 1 minus 1 over n comma 1. Dude, I'm still thinking about how I made the mistake of turning my eyes into ones, and I'm like, oh, I should put dots over these ones, but no, okay. Is the empty set. So I think we want to let x be between 0 and 1, exclusive. And I feel like it should be completely fine if we just let epsilon equals 1 minus x. The idea being, we want to show this gets very close to 1, but not actually touching 1. Wait, I should, now it's Hunter x Hunter. I should back up. So it can't be outside the interval 0, 1, because those numbers literally aren't included. And so none of these individual intervals will include 0 or 1 or anything outside of it. So if you intersect it, everything else, the intersection isn't going to change that. And we need to prove that nothing between 0 and 1 is going to get included in this intersection. And we do that by saying that for any value of x between 0 and 1, we can always name some member of the sequence that is between those two terms, and once you intersect the sequence from h sub n to 1, this x gets chopped off. That's the argument. So do we want to even involve epsilon here, or just do an epsilon n proof without using epsilon and just use 1 minus x for everything? Maybe just use 1 minus x for everything. Maybe just not worry about epsilon. For any x between 0 and 1, there exists an n greater than n, sorry, big N greater than small n, no, there exists an n, there we go, I'm getting my, there exists an n such that for all n greater than n, maybe you do want epsilon greater than 0. Because this doesn't feel right either. Like, I remember doing this exact same thing in class, and Zach was kind of like, maybe not. Myself, just keep it more. I feel like the epsilon shouldn't be necessary. But let's just do it. And just turn this into a normal epsilon n proof. Oh. Yeah, I guess that's a good point, SPQ. You don't need to make the point that it's every n after that. You just need the one. Okay, I like that. You just need to show that there is a single interval that does that. Um, and now what's the choice of? I'm a little bit. I almost forget how to do this part for finding a choice of n. Can we just like solve this for n, I guess? Does it make sense? This is something that Obi already did. What did I do wrong? Assume there is an element x from the set. An element x from the set. I don't think we've done the Archimedes axiom. What is that? I don't know why I ever bother looking at Wikipedia. How do you prove an axiom? I don't know what's up with that. For an x greater than 0, there exists an n in n such that 1 over n is less than x. Oh, it's not a real axiom? Okay. So I mean, I don't know if I would want to use that because it's not something we covered in class. Like the direction that we were going was trying to basically reframe it as an epsilon n proof. So I was trying to actually work that out, but it's a little bit weird. It's not the exact same format that I'm used to, which I'm getting tripped up. And for every x, however small, there exists a natural number larger than 1 over x. I was getting... Okay, yeah, I did just realize that I dropped the absolute value. And that's part of why I was getting tripped up. It should be absolute value of that. Yeah, I guess maybe you don't need to make it an epsilon n. Like maybe this is all just frills. And Bob, what you said is the real like meat of it. Okay. She asked a question on a verbal exam, made up the answer on the spot. Oh wow. Well, hey, good job. I guess I should say let x in 0, 1. Now, for any choice of x, let n equals, are we saying 1 over x here? So we just need to name one of the n's where this excludes it. So if x is 0.9, I want to do some like computations to like convince myself of my choice here. But plus 1 for n? Let n plus 1 equals 1 over x? Why is 1 over 0.9 equal to 1, Wolfram? What? Oh, it won't be strict? Well, we have seen, I was thinking equality because we only need to name the one element. I'm more confused by what Wolfram Alpha is doing here. Yeah. It's like start with the answer, multiply by 1, anything times 1 is itself, so that's the answer. 1.111 is right though. So if we let n equal 1.111, what is it as a fraction? 10 over 9? 1 minus 1 over 10 over 9. This should be higher than 0.9. That's not higher than 0.9. What did I do wrong? I guess I said ceiling plus, or, and we're potentially saying plus 1. Wait, x can't be natural. Oh, 1 over x could be natural, though. So I'm actually saying that I would take, or we're actually saying that we would take 2 here? That's not higher than 0.9 either. Because if you did roof to get to 1, plus 1, no, roof will get you to 2, but I don't think 3 is the answer. 3 isn't right either. One minus 1 over ceiling of 1 over x plus 1? So I assume what you're doing is you're saying x equals 1 minus 1 over n. And then you're solving this for n to get that SPQ? What if we did ceiling of this? Like, I don't know what your thing is SPQ, but, or I guess we could do the plus 1. I'm still not sure exactly. I want to figure out why the plus 1 is supposed to be there. But I assume we still want the plus 1 for the case where it's rational. So if we take x equals 0.9, we do 1 over 0.1, which is 10. Yep, ceiling of that is still 10. So we take n equals 11. 1 minus 1 over 11. Does this work? 909, okay. That seems better. If we take... So if we took x, so if I didn't do the plus 1 and we just had 10, we get 0.9 exactly, okay. So that's why we need the plus 1, because words. You're not actually rounding up with ceiling if you happen to already get a natural number. And you need to get higher than that. Okay. Okay. I feel convinced by this choice of n. Well, now I have to make the claim that n is greater than x, which doesn't... This is a much harder thing to prove is greater than x, isn't it? Let's see if we can use some inequality magic to make it not that bad. So, oh no, this is the greater than side. I don't know how you do that part of the proof. Like, how do you show that this is greater than x in general? You need to somehow change the ceiling to be something that's a bit easier to solve. You can name something that's greater than this. Is something, if we did another plus 1? could we say that 1 over 1 minus x plus 1 is greater than ceiling 1 over 1 minus x? Like, is that a generally true thing? Greater than or equal to, I guess. So I guess greater than or equal to is acceptable though, for the sake of that, because it's still greater than x. Well, I guess we're starting with what we want to prove. N is greater than 1 over 1 minus x. Hey, Anders. Actually, I'm glad you're here because I've been working on that proof that we were talking about this morning, or I don't think it was morning for you, but during section 1 of Zach's class. So it was this one here with the open sets. And so I think you were saying that we can kind of turn this into an epsilon n proof, which I really liked at the time, but then when I actually tried it just now, it didn't seem to actually work out if I tried to write out the entire proof. And so SPQ and Bob were suggesting a different strategy where you do a proof by contradiction and let x be a member of that like interval, but then I'm getting tripped up on this too, so. So I don't know, it turned out to be, this has been harder than I thought it was. I thought this would be like a quick thing. Oh yeah, no, so like the argument by contradiction is completely separate. I don't remember anyone mentioning a possible argument like that during Zach's class. But showing it's like, making it into an epsilon n proof is like a little bit harder than I thought it would be. And sorry, if you're just here to like lurk, then I don't mean to like make you talk, but just because you were discussing the problem earlier, I was like curious. M greater than 1 over 1 minus x. Well, I guess I'm doing it backwards. You join the call? Oh, do you want to talk? If you want to like hop into voice chat in my Discord, I wouldn't mind. Yeah, as long as you're okay with it. No worries. So SPQ, does your first statement, like, do we know that's true? And or we just take an n that's greater than 1 over 1 minus x? I guess there's certainly an n that's like that.
Hey, Dom.
Oh, hey.
Can you hear me?
Yeah.
Okay. Let me mute the stream for a second, so I don't hear myself.
No worries.
Okay. How can I write?
Oh, do you want to actually like show your screen to explain, or are you gonna like try and just like verbally tell me?
Whatever you prefer.
If you want, we do like a whiteboard like we do for the class, or you could like share paint or something.
Yep. Where is the board? Here. Open board, and let me share the screen.
Okay. Is it okay if I show this on stream too?
Sorry? Can you repeat?
Is it okay if I put your screen on the stream as well? Or if I show my Discord?
Ah, yes, sure.
Cool.
Open interval from HN to 1. So we want to prove that this is the empty set, right?
Right.
And since these are open intervals and we're taking the intersection of all of them, if we have one element that is not in at least one of the intervals, then we can automatically conclude that it's not going to be in the intersection, right?
Right.
Okay. So if X is an element that is not in the open interval 0, 1, then X is not in, for example, H1, 1, right?
Right.
And therefore X is not in the intersection, right?
Yep, that makes sense to me.
Okay, this is the easy case. But if X is in this interval, the idea is that we're taking an element, let's call it X, and we want to find one of these intervals, which are all something like this, right?
Right, so that excludes X.
We want to find some Hn that exclude the given X. Okay?
Right, yeah.
Okay. So we know that Hn is a sequence that converges to 1. Right?
Yeah.
This means that for every positive epsilon, we can find some natural number n that for every little n bigger than this n, the distance between Hn and 1 is less than epsilon, right?
Right.
This is the definition of Hn converging to 1.
Right.
Okay, so we're going to pick 1 epsilon.
Okay.
Our epsilon is 1 minus x, which is this distance.
Oh, okay, yeah.
Okay. So we can say that there exists some particular natural number n that for every natural number bigger than that, the distance between Hn and 1 is going to be less than 1 minus x.
Okay.
And what this means? hn is less than 1, so this is 1 minus hn, right?
Right.
And this means that x is less than hn.
Oh. I got to that step of like that h sub n minus 1 is less than 1 minus x, but I didn't realize you could just say it that simply. That makes sense when you explain it to me, though.
Right. Give me a minute. I need to
Oh, sorry.
lower your volume because it's saturating.
Oh, sorry.
Yeah. Sorry, what did you say?
So I had gotten to that step that you said with absolute value h sub n minus 1 is less than 1 minus x, but then I didn't realize that you could just get to x is less than h sub n and you proved it. I didn't.
Yeah.
I thought it'd be something more complicated, I guess.
No, this is cancellating, and
Yeah.
we can. And so we are saying that we can find some value that exclude the given x. So this means that we can take this h and 0, right? And x is going to be less than this value. Therefore, x is not in the open interval h and not 1, and therefore x is not in the intersection.
Okay.
Right.
That's perfect.
So,
Thank you for explaining it. Or sorry, what were you about to say?
Therefore, we already covered all of the cases, and this means that this thing must be the empty set.
Okay.
Do you agree?
Yeah.
Okay. Great.
I just thought it'd be like something harder, I guess, but I really like that proof. Okay. Well, thank you.
Oh, thank you.
All right. I'm gonna dip out of the call and I guess keep on working on some of the other problems, but I appreciate the explanation.
Okay,
Or unless you
sure,
want
no
to keep on talking about other problems too, I'd be happy to do that. But it's up to you for how much you want to talk.
I should be go to bed right now.
Okay, no worries. Well, the invites out there
get a
never
break early
do want to
tomorrow.
talk. It's an open invite if you ever do want to talk in the future. Then.
Oh, okay. Thank you.
Okay. Well, I guess I'll see you for now.
Yeah.
Bye.
See you then. Bye.
Okay. Awesome. Okay, that proof makes sense. Thanks again to Andrews for hopping on the call and to like speak English, which I know isn't easy. And then okay, so sorry, let me catch up with what you've been writing. So I think that your way is also like completely valid. The way that Andrews explained it is very like in line with what we did in class. So it makes a bit more sense to me, but it would be cool to understand that way too. Okay. You consume more energy drinks, yeah. Greenery prove the intersection empty using the PS exercise. h sub n minus 1 is equal. Oh, that's okay. That's probably the best way to do SPQ, I feel like. I think it's a little, I assume that's a little bit out of the realm of at least what we've been doing in the real analysis so far, but that does seem like the most efficient way to prove it, given that we've already done the case for a closed interval. Okay. Well, I meant for that to be like a 2-minute thing, just so like reconvince myself of this proof, but turned out to, I turned out to need a lot of explanation, but at least I get it now. It's almost, yeah, almost trivial. It takes me like 20 minutes to understand almost trivial things, but it's just how it goes. Okay, and so yeah. I mean, I feel like if I tried to pull that during the actual real analysis class, Zach would tell me to prove that the connection between like the closed interval and the open interval, or like that would need some justification. Which I guess maybe it does, depending on how rigorous you are. I don't know. Okay. Prove it out. Oh my god. No, I was struggling enough with the other proofs. Okay, so what were we doing for 3? Because we kind of ended with part D, but it seems like it was kind of blending into number 4. We said about all sequences. And so we were saying that a bounded sequence, regardless of whether it converges or diverges, has a convergent subsequence, at least one. And I kind of want to Google the Bolzano wire stress theorem because it was mentioned. I think it's the last time I was also working on real analysis on stream. But we hadn't actually gotten to it yet. So let's go and do some Googling. Your mic was fine. I didn't notice the volume oscillating. Your volume was convergent. No, your mic was completely fine for me. Like there's like a little bit like background noise when you type and stuff, but it's really nothing obnoxious, so. Or I guess there's also the VOD if you really want to like listen back to yourself too, but your mic was completely fine for me. I feel like this is explaining things that are a little bit beyond, because the space is bad. Oh, wait, actually, this is the exact same concept that we were just talking about. Okay. gonna spend more time with this on Thursday too. Oh, okay. I'm gonna need it, Zach. So thank you. Because actually, maybe this is exactly the explanation that is kind of relevant to the class with in here, the limit that it converges to is included in the space, but here it's not. Okay, good the proof though. Oh yes, I didn't. I was still reading like the introduction. Every bounded sequence of real numbers has a convergent subsequence. Okay. It's going to be a bounded sequence without loss of generality. Assume that every term of the sequence lies in the interval 0, 1. I guess because you can always scale it. Happy voice reveal. Divide 0, 1 into two intervals 0, half and 1, half, 1. This is not a partition of 0, 1. That seems like a partition of 0, 1. Why? What does partition mean? Does a double include 1 half, I guess? I don't know what a partition actually means, I guess. Oh, it has to be an open interval. I don't know if that part, maybe that's just a little aside if you're already familiar with the idea of a partition. Oh, wait. I remember that for a Riemann sum. Wait, why isn't this a partition? Maybe this probably is an important point to get stuck on, but... Okay. Maybe let's just keep on reading. I mean, partition doesn't mean that much to me anyway, so... Remember what I sub 1, which has length half. Okay. Oh, okay, wait, I don't even, this is a separate proof for Rn. Let's just look only at this. Divide I sub 1 into 2 halves, each with length a quarter, okay? This one which contains infinitely many. Wait, they are making horizontal cuts. No. Wait, never mind, never mind. These are all vertical cuts. I put it back in my terms. It's because if I can't visually see or do something, then I usually don't get it. So I think about a sequence in terms of its graph. Construct nested intervals, I sub 1, I sub 2. Each time cutting it in half, each time one of those intervals has finitely many terms. The other half has infinitely many. Okay. And you get down to basically there's a bunch of finite intervals and one infinite. Or prompt 2. I've already forgotten prompt 2. I was just working on that too. Ah, okay, the infinite intersections. Okay. Notation's slightly different, but it's the same, saying the same thing. Wait. Well, these are for convergent ones, though. I guess the more interesting is the divergent, but I guess it's still the same argument? Or I guess, oh, that's because, like, prompt 2 is building towards it. And that's why, that's how these are connected? Oh, okay. And, like, we're just saying, like, I think Obi was asking how 2 was connected to 3, or something like that, so I guess that's it. For chefs, sometimes a struggle. No worries. If I tried to do this, it'd be much worse. So I don't blame you for any of this. Each interval contains an infinite number of terms of the original sequence. Wait. Each interval contains an infinite number of terms. I thought it was only one of them contains an infinite number of terms. Oh, at least one of which. What the heck? I'm losing track with the XM, like, the prime subscripts. Like, I can't handle them. Yeah, so I just know it just means, like, you know, I think it's the indices of n associated with the infinite part? Oh wait, never mind. They define x sub n prime here. Maybe I should actually read. Okay, so x sub n prime is the sequence, it's the subsequence of x sub n. BC626, thanks for the follow. Who's x sub n consisting every term that lies in I sub 1. So x sub n are the terms of the sequence that are in the first interval, I think is all that's saying. Because we've only defined the, if someone want to refer to the actual value of the sequence rather than the indices is how I'm interpreting this. So we take that I sub 1, divide it into two halves again, at least one of which again has infinitely many terms. Okay, so I1, I2, etc. are all the infinite subsequences, or the intervals associated with the infinite subsequence. Okay. A subsequent z sub n of x sub n made up of one term from each interval I sub n. This subsequence is clearly Cauchy. For all n, there is an m comma n greater than n, such that z sub n minus z sub n is less than 1/2 to the n. Oh wait, so I was actually on the right track with bringing in Cauchy sequences? That was completely like... I thought I was just like relating it to something that wouldn't actually apply. So I'm starting to understand like how exactly this statement works though. Z is one term from each interval of I sub n. They use the word clearly. And that's a statement that I'm getting stuck on. Frickin' clearly. Infinitely many numbers in I sub n. Choose one. Like a number between... I just say like 0.5, I guess. Or, well, 0.5 is probably bad. But let's say 0.3. So we don't get mixed up with the 1/2. This needs to be in I sub n. That's the thing, I don't know. Jefferson gets an element. Okay, you know what? The way ask me to like say a number. It's just like it's an element as a representative. Okay, yeah, I got that far, but then how do these like oh, well, I don't know how all the terms are within 1/2 to the n. I guess that's where I'm getting confused because I guess 0 to 1. We keep dividing it in half, and let's just say, like, if we only ever took the upper half, there's like a worst case scenario where an element over in this very upper part would be 1/2 apart from the very first one. I forgot to take down my webcam. So shouldn't it just be 1/2 and not 1/2 to the n? That's what I'm getting confused on. Like, why are they Cauchy with 1/2 to the n and not just 1/2? Yeah, I guess I get how they're all subsets of each other if you just take the one term. But needs to be true for all the intervals, doesn't it? Or because we're taking one element from each of the intervals, I sub 1 through I sub n. So it should be also true for I sub 1, shouldn't it? Since z sub n is in I sub n, z sub n is in I sub m, but by construction... Oh yeah, we're taking it past some point. Okay, well, I forgot about, I guess, this part. but okay. I see. I'm getting it mixed up. We're not. Or is it? I was getting mixed up, I guess, with maybe the chain of I's. I sub 2, I sub 3, ... less than, and then we have this I sub big N. And what I didn't realize is that I sub M and I sub N, or you can interchange them or whatever, are past this. I thought that these two would be over there for some reason. Okay. And then it's like, you know, I sub N could be anywhere over there, then. Okay. Hmm. I need to let this sink in for a bit more before I really get it, but I think I feel comfortable enough with what's happening. Now, because I never actually, there was the, I was working on a problem involving Cauchy sequences, and I could do that, I think a convergent sequence implies that it's Cauchy, but I couldn't do the reverse direction. I already understood it. I mean, I feel like I half understood it, but coffee, Cauchy. So I think I understood it anyway. I just wanted to like, the Cauchy implies convergence and convergence implies Cauchy, both ways. It seems. Well, actually, no, this exact thing was saying that it doesn't necessarily. It only implies convergence if the limit is within the interval. Or if the limit is included as an element in the sequence, I guess. Or you only have guaranteed convergence. For real numbers, they're equivalent. Okay. So the Cauchy sequence is bounded. I think I was trying to do that. If it's Cauchy, then it's convergent. Okay, I think that's what I was trying to do. Or no, I think I was doing the reverse direction. I don't remember. Convergent to Cauchy is the easy direction. I don't. Okay, well, let me just look back at Zach's Discord because I posted my work, I think. Which meeting? 6? Okay, I did convergent implies Cauchy. And that's what you said is the easy direction. Okay, yeah. Okay, yeah, so that one wasn't too bad, but Cauchy implies convergence was not easy for me. And this is the proof right here. So maybe I should actually look at this. A sub n sub k from if Cauchy then bounded. Okay. I should probably look at that lemma up here too then, but let me just focus on this first. And we know this monotone subsequence exists because we can probably construct it, or boson wire stress or something. n sub k. So n is an index of the original sequence, n sub k is an index of the convergent subsequence, or yeah, greater than n sub 1, which implies a sub n minus a sub n sub k, absolute value is less than epsilon over 2. So choose terms late enough in the original sequence and the subsequence that are very close together. Okay. Now what is just A? Is it supposed to be L? I'm going to take this A as meaning L, because I don't know how else this statement could possibly, or what else it could possibly mean. You take N, NK, I think it was like, okay. It's weird, because they didn't say what A is without a subscript. Okay, yeah. Max, N comma N sub K is greater than or equal to the max. Well, they didn't say what N was either. I hate this proof. Because I don't get this proof, and I hate things that I don't understand. I can kind of see like the idea of where they're going, I guess, with epsilon over 2, and they're gonna, I guess, add these. But they didn't say what N is. We have N1 and N2, but not N. I assume it's N1 comma N2, but I hear they're playing fast and loose with their letters, or they didn't proofread it or something. Yeah, I should just look at SPQs, maybe, but... And why are there 2 lines there? Is this triangle inequality? With a sub... Oh, I guess it is. They did a plus a sub n minus k minus a sub n minus k. Okay, I think I get the bones of this proof. Maybe I should try writing out in my own words. Let me look at what SPQ wrote. Cauchy to bounded is easy to prove. By definition of Cauchy... Oh, okay, so this is for bounded. There exists an n in n such that n greater than n implies a sub n minus a sub n is less than 1. Okay, yeah, just taking random value for epsilon, I guess. Now a sub n is equal to a sub n plus a sub n minus a sub n. Which just makes a lot of sense to someone who's just listening right now. It's less than or equal to a sub n You're allowed to split out that A sub big end? How do you know A sub big end is positive? Or is that... No, that's triangle inequality. Never mind. Oh, or is there an error in their SPQ? Now, let me see what the site wrote for Koshim playing bounded. Oh wait, this is basically the same thing that you were doing SPQ, I think, because it seems like it. Same proof SPQ? Okay. Non-areas mess up the order. What's your proof theorems? Oh, okay, okay. Look back at what SPQ wrote then. Oh yeah, and that, so that doesn't have to be the supremum. That can just be any upper bound. So the +1 being arbitrary isn't really an issue. It's derived the result from something dependent on this exact result. Okay, I want to try writing this out where we don't randomly have big ends that... Oh, Anders. I should figure out what that would be. I could have like that's a good idea. Like I could have like a circular arrow that spins around on itself. It's like just have it like actually like spinning. I think there's a better one though. I love that idea. A little sign that says "Prove me." Yeah. Oh yeah, I can do the text over it for sure too. Or I mean, or maybe like proof or something like that. It can't be too many letters. But I have a couple of like animated emote slots that I need to fill up, so that'll be coming soon to a streamer near you. Okay. I just want to write this out for myself. I think it's gonna help me remember it. Oh, what am I writing? Can you make the sign spin too? Oh yeah, I could make that spin too. That might be funnier. I'll have to try it. Okay. So we let a sub n sub k be a monotone subsequence. I'm not going to do the curly braces. Since a sub n is bounded by Cauchy, I'm just going to make that my justification, hand wave the rest. Then a sub n sub k is also bounded. Therefore, a sub n sub k converges. Take a sub n sub k approaches L. This is an emote for any inappropriate argument. Feels dank, man. Is that what does Feels Dank Man look like? Is that like a better Twitch TV thing? Oh, it's on Franker. I can get that. That's funny. Actually, wait, it only take me like 2 seconds, I think. Franker phase C. Connect with Twitch. Public library. Library. Feels Dank Man. You have to go, Anders? All right, see ya. Actually, oh my god, I've been doing math for like 5 hours. I'm probably going to go raid Zach in a minute. But either way, Anders, thank you for hanging out. And I'll see you around. You might need to refresh the page, but I just added in Feels Dank Man. Let me refresh my chat. Yeah, it's in here. There you go, SPQ. Okay. Then a sub n is convergent. Okay. So after this point, the proof on the website starts to go off the rails for me. Choose n sub 1, n sub 2, such that what's happening here? Okay. N, or not like this. N comma n sub k for the subsequence a sub n sub k is greater than or equal to n sub 1. And since it's Cauchy, well, does being Cauchy imply this though? Well, we're just choosing. Not necessarily, yeah. Okay. This implies that we can find an a sub n minus a sub n sub k that is less than epsilon over 2. That feels like... I can see why being a Cauchy sequence would let us have this property, I guess. I think. Because they should be getting infinitely, or they should be getting very close together, so, and one is subsequence of the other. So I guess I'm on board with this. And then we want in n sub k also greater than or equal to n sub 2, which implies that a sub n minus k, or a sub n sub k minus L is less than epsilon over 2. Or we can take it in n sub 2 such that that's true. Oh, I know why they do the n without a subscript now. Well, no, that doesn't make sense. Oh, God. Okay, now... I guess the big N is supposed to be the epsilon n proof n. Same with the small n. But I feel like... Is this presupposing the limit already exists? I'm sure it's not. I just need to understand why. Like, I wish they explained where that big N comes from. See, that's not a typo. Oh wait, the little n is here. Choose indices greater than the max of these two n's. I think it is supposed to be n sub 1, n sub 2. I don't see what else this n could possibly be. I'm going to call this a typo, maybe. Because I still don't know what the point is of doing the whole n sub 1, n sub 2 thing. We never use n sub 2 either. Okay. So we're going to take n sub k greater than or equal to max n sub 1, n sub 2. I don't, the implication arrow weirds me out here too, so I'm just going to put a period and then say a sub n minus L, just in a vacuum. I'm not even saying this converges yet. By triangle, actually, a sub n minus L is equal to a sub n minus L plus a sub n sub k minus a sub n sub k. By triangle inequality is less than or equal to. We're going to take a sub n and a plus a sub n minus a sub n sub k plus minus a sub n sub k minus L, because it's absolute value, we can change it into plus Shouldn't they have opposite signs? Oh, because it's the plus and the minus. They do have opposite signs. Which is less than epsilon, because it's these two added, which we already said were less than epsilon over 2 for a given nk. And now going back to what we started with, a sub n minus L is less than epsilon. Okay. I think I'm on board with this. Now I've actually written out for myself. Okay. Well, I didn't mean to, but I've ended up doing math for 5.5 hours. That's probably one of the last times I've done math in a long time. I've just been having a lot of fun today with this. It looks like Zach is live, and I'm getting a little hungry, so let's go over and raid Zach, I think. The real analysis class, well, I was just working on here. Well, not exactly this, but related to this, is starting in 5 minutes. So let's all go watch and see what they have to say about the problems. Slash /80 to the 2i pi. Good. Okay. I'm back tomorrow to play games, and then my next math day will be on what's it called? Tomorrow. Sorry, my next math day will be on Thursday. And for anyone on YouTube, I appreciate you too. I should I can't raid from YouTube to Twitch, but I'll drop the link in chat for anyone who wants to go see a live real analysis class. So yeah, whether you've been chatting or lurking, I appreciate you. On YouTube and Twitch. So yeah, tomorrow will be video games. Thursday will be math. And yeah, thanks so much to everyone who's been here. I appreciate you all. And with that, I'll see you later. All right. And bye, SPQ.